All right, thanks everyone for being here, attending our session today. My name is Dre. I'm a developer advocate for the Google Cloud Platform. What that means is that I do two things primarily. One is to bring some of our best technologies to developers all over the world, both on the Google Cloud Platform and also open source like Kubernetes, Istio, gRPC, Knative, and so on and so forth. The other thing I like to do is to make sure that our experiences are really, really good, especially for Java developers. And so for that reason, I created a project with the engineering team and with Pivotal. It's called Spring Cloud GCP. If you have any Spring Boot application you're running, you're trying to use on Google Cloud, check it out. I'm also a developer for JHipster. I created the Kubernetes and Istio generators for JHipster. If you haven't used JHipster, please check out some of the sessions. It allows you to create, rapidly generate applications really quickly. Anyways, if you have any questions, you can find me on Twitter @Satanism. And if you want to find more materials, you can go to my site, satanism.me. Okay?
Cool. And I'm Eric Bottard. I'm a software engineer at Pivotal, currently working on the Riff project, which we'll cover in this session. And previously, I was working on the Spring Cloud Dataflow and XD projects. And I guess people who are familiar with those will see some similarities. I'm also the maintainer of the Spring Shell project, and you can reach me on Twitter on that address. And obviously, feel free to come to me during the conference.
Okay, so what are we gonna see here? Let's take a look. So, hey Eric, what if today everybody is kind of deploying containers and stuff into a Kubernetes cluster. What if I just have a function I want to deploy into a cluster? Like, what is the process to do that today?
Well, you would need a Kubernetes cluster.
Okay.
I guess you have one already.
I do.
And then you'll need something on top of that. So I can show you Riff, which stands for Riff is for functions.
Okay.
And maybe we can go from 0 to running function. In no time, right?
So I'm gonna time you for this as well, if you're okay with that.
Oh, you're gonna do that?
Yeah, I will time you for this. Yeah. All right. Ready? Are you good to go?
Yeah, sure.
So you have a cluster with nothing on there.
Yeah, and a QWERTY keyboard, and I'm French. So let's go. Let's install Riff first, right? So Riff comes as a command line tool, and you can install it easily by just doing Riff system install. And what this does is that it grabs in this case, a stable version of it, installing the different components that Riff is built on top of, one of them being Knative, which will be the subject of that talk. So it installs that. Knative itself is built on Istio, which is, let's say, Envoy for Kubernetes. So it's applying a lot of Kubernetes definitions to your cluster, each of them in their dedicated systems. And once Istio is installed, then it can act as the service mesh for all your apps, and applying the sidecar pattern to intercept requests to your apps and reroute them and monitor traffic and act on those and create different routes, stuff like that. So it does all that for you. So it's a bit complicated to install, so the Riff CLI makes it easy to do that and making sure that everything is correctly set up. So we see it's spinning up currently, and then it's going to go to the Knative install. Knative itself is, as we'll see, based on 3 core concepts, serving, build, and eventing. So we'll see resources for all of those being installed in turn. And what that does is that it allows you to scale your functions from 0 to n and back to 0 when there is no traffic. All of that thanks to custom resource definitions in Kubernetes, so that you extend the Kubernetes platform in a simple way and deal with Kubernetes concept that you are familiar with, the Kubernetes kube control tool and stuff like that, right? So it is installing the serving version. So it's going fine, I guess. And then what we'll do once this is done is to set up Riff for the namespace we're going to work on. So I guess we'll use the default namespace. So I'm going to do that now with Riff namespace in it. So what this is going to do, and I'm going to ask you, do you have credentials to your Docker registry of some sort?
Yeah, actually, I think it's under keys.
OK.
Yeah.
So you're using GCR, right? So I'm going to use that.
Yeah.
And I guess push service account. OK,
yeah,
cool.
That's right. Yeah.
So when I do this,
namespace
default, so
default, yeah.
initting the default namespace, sorry. What this does is that it registers a custom build template. This is a Knative concept. Creates a custom build template for building functions with Riff, setting up the credentials as a secret in your service account, and so that everything is properly set up. And then we'll create a function from source. Yeah. So I think you had this thing you wanted to...
Uppercase function.
Yeah, it's written as a shell function, right?
Shell script, really. A lot of the serverless stuff I've seen so far has been JavaScript, but this is a shell script.
That's fine.
Yeah. Oh,
okay,
nice.
so let's take the Git coordinates for that, and we'll create the function, right? So what I'll do is Riff function create, give it a name, so it's doing uppercase. The coordinates for that was here, so it's Git, right? I'm going to push that to an image in your repository. That's fine. Yep. So here I'm setting up the image names that I'm going to use. Let's say gcr.io / I know you have a environment variables for that, right?
It's called GCP_project.
GCP_project. Yep. And then we can do something like oops, sorry.
Yeah. Different keyboard. Different.
Yeah, you're going to see a lot of that. Sorry. Let's say about Devoxx. The actual function was in a shell script, as you said. Yeah. So let's point to that. This was uppercase.sh, right?
Yeah, uppercase.sh. Yeah. Is it 1- or 2- for the artifact?
It is actually 2 dashes. Okay. And I think we're all set. I'll add the verbose flag as well, so that we can see what happens. And we can explain a bit quickly, but for some reason it keeps doing one. Okay, I think we're all good.
Wow.
So what it does now is that it creates a Knative service, which itself is creating a revision. So it's picking up the first revision, 001, and grabbing the logs from here. And we're good. This is creating a build. We can see it proceeding on the right. Several steps there. It's already at step 5. If you look at the upper right corner, checking out the source, invoking a build pack, the build pack builder image using that concept from Cloud Foundry and Heroku, and packaging the app with a Riff invoker so that it can be turned into a Knative service. And that's done. And then I can try it, right? Yeah. So we will need to look up the IP address of the cluster, but we can do that here as well pretty easily. So Riff service invoke, was upper. Let's give it some text, and we'll pass arguments to curl, so we can do -d and I guess Devoxx.
And would that just work?
And yes, it did.
Wow.
Devoxx in all uppercase glory.
Wow, that's pretty incredible.
You
did it in about 5 minutes to deploy, and then aside from the getting used to the keyboard, the total took about 6 minutes. That was pretty cool. And while you're going through there,
how was the buzzword bingo going?
Yeah, so I don't know if anyone here. All the details, yeah. I think we hit everything that we wanted to say.
I missed polyglot.
Yeah, we got serverless, function as a service. We have custom resource definitions and polyglot build template, and wow, that's pretty good. Let's go back and check. Also, we can talk all the buzzwords that we want, but did we actually hit everything we want in the abstract? So here's the abstract, the first paragraph that we wanted to say. So we wanted to go from function source code to Kubernetes in 5 minutes, which you did, which is incredible. Yeah, very nice. And then we did talk about Kubernetes, Istio, Knative, and Riff. So I guess we're done here.
We're done. Thank you very much.
Thanks, everyone. Yeah, thank you. Yeah, Vinecast Room is the other one. I'm just kidding. Oh, wait a second. We did forget one thing, a Spring Call function. I guess we're going to talk about Spring Call function in the next 3 hours. Is that right?
Oh, OK. So you need to stick to the end to see that.
Yeah.
OK.
But that was pretty incredible.
Was it?
Yeah. Okay. I mean, going from an empty Kubernetes cluster to deploying the entire serverless system to running the function from source, that all took really about 5 minutes.
Yeah, that's cool. And now the Riff and Knative systems are installed, obviously, so you don't need to do that twice if you want to deploy new functions. Right. And that's what took the most time, I guess.
Right.
So I guess we'll need to explain a bit what happened, right?
Right.
Maybe.
Yeah, so there's a lot of things that's happened just behind the scenes in order for this to work, right? So there's a lot of things we do need to understand in terms of how Kubernetes works under the cover. So we're going to cover that. We're going to open up Kubernetes and truly understand how it works. And then we're going to talk about Knative and Riff and all the things around that.
Absolutely. How Knative itself is architectured, why it came to be, and where Riff relates to that. And I guess, yeah, because Knative is made of several parts, 3 of them actually, we'll cover them each in order. And then we'll talk a bit about Spring Cloud function, so stick to the end. And with the time that's remaining, we'll try to craft something from scratch for real.
Yeah, for real. Yeah.
Okay.
Exactly. So that's gonna be incredibly dangerous thing to do, just so you know, because we're gonna be doing everything live. Just put everything together. Here's the high-level agenda of what we're gonna cover today and the timing. So we're gonna separate into maybe 3 different sections here, and then maybe a 10-15-minute break in between. And let's go.
Okay.
Yeah. All right. So. Kubernetes has really changed a lot of the ways that we think about how we deploy and manage our applications today, right? It came from like the old days where we do have to do everything with a script, or somebody has to manually deploy and configure your servers and so on and so forth. With Kubernetes, really with containers Kubernetes, now the way that we think about deployment is by declaring the desired state that we want. Right, so rather than saying the steps of what we need to do to get there, we just define the desired state of the end state. And in this case, for example, all we need to do is to say, if I want to deploy 2 containers of something, all I need to write is something in Kubernetes, like a deployment, something Kubernetes can understand, and say I need 2 instances of that. Right, and behind the scenes, we're going to, first of all, we have the container created that has all the things that we need in the runtime. But the configuration file that we create will be pushed into the Kubernetes master node. And then behind the scenes, there will be a scheduler that's doing some kind of reconciliation loop that's going to keep on waking up and say, hey, do I have something I need to schedule? What is my desired state? What is my current state? And if there's a mismatch, then the scheduler is going to say, oh, and let me go ahead and deploy this container onto one of the nodes. The scheduler will have heuristics and algorithms to determine which of these nodes to deploy to. And one of the easiest way to kind of see this at work is what if we want to run a new container here. So I'm going to do the watch here on just one pod, or sorry, a few of the pods in my default namespace. And I'm going to do kubectl run, not that one, nginx, right? And the image is the nginx image. So I'm going to do that. And I'm going to say replicas is equal to 2. Right? And again, we're telling Kubernetes using its own language, using the deployment resource to tell it I need 2 instances of Nginx running. Right? And very quickly, yeah.
How many of you are familiar with Kubernetes? Maybe we could. Half of the room, I guess. How many of you have heard of Knative? Fewer. Okay. And OK, that's good.
Yeah. And the reconciliation loop here is that if I were to modify the state of my actual environment, right, something's running behind the scenes to make sure, oh, wait a second, now you have only 1 instance running. Let me go ahead and create the second one, right? Because I constantly want to have 2 things.
OK.
Yeah. But that is at the high level of how this works. This is what maybe I have presented for a while in terms of having people understand what Kubernetes do behind the scenes. But there's a lot more things that's actually involved behind the scenes. First of all, what we created is a deployment, right? But deployment is really just a high-level construct to define the application and the number of instances. And maybe I need to do a rollout. Maybe I need a new version of the app. I use deployment to define that. But behind the scenes, from deployment, something else gets created. It's called the replica set. Replica set is just basically saying that from this deployment, at this one particular snapshot of it, I need to have 2 instances of my app. In this case, I have a replica set called nginx. And from there, from the replica set, it actually is the one that creates the pod. But again, it all sounds very magical on how these things are being created. To truly understand how Kubernetes work will help us understand how Knative and Istio and all of the other new things that's building on top of Kubernetes work as well. And so let's dive into what happens. So for this, I'm going to do a little role playing. I guess, Eric, why don't you be the Kubernetes master node, maybe?
Sure.
Yeah.
My pleasure.
Yeah.
What do I need to do?
And
store things?
Yeah, currently I'll be the user. And the first thing I'm going to do is is that your phone? Ooh, that's nice. Can I keep it? Just kidding.
Sure.
So I'm going to put my deployment. Oh, that's my phone. Never mind. I'll definitely keep it. So I'm going to pull out my phone and say, put in a document and say, hey, in this document, I want to have run Nginx in 2 instances. And I'm going to use my command line to send it to Eric, who's the master node right now.
OK,
right?
so that document is typically you interact with it as a YAML file, right?
It's a YAML file, yeah.
OK.
Yeah.
So I'm going to take it and pocket it.
Yeah, pocket it. What?
Yeah.
What? Just store it? What?
I stored it.
Yeah,
it's safe.
Well, don't go home with it. That's my phone. Anyways, so from there, right, Eric stored it into his storage, which is etcd mostly. And then behind the scenes, there's actually a controller that's going to do the reconciliation loop. So
you're the controller now. Yeah,
so let me put on a different hat. I'm the deployment controller, right? So as a deployment controller, I'm going to constantly ask Eric, hey, do you have a new document for me that's for deployments?
As a matter of fact, I do. Here
OK.
it is.
Well, can I take a look?
Yeah.
So the controller, in this case, will take a look at the document that's in Kubernetes and say, based on this definition, am I maintaining the state that I'm supposed to maintain? And if I am, perfectly fine. I'll just say in the code. But if I'm not, then I'm going to go ahead and create a new document here called the replica set. Right? So the controller is physically creating some of these subsequent documents for me. And once I created it, I go back to sleep, and then I wake up and say, hey, Eric, do you have another deployment?
No, I don't.
No? How about now?
No.
Are we there yet?
Almost.
So we got 3 hours to go. Now, anyways, so
no new deployment.
No new deployment. Then nothing gets returned, and I don't do anything. But if you do happen to have one, then
because you were the deployment controller, right?
Because I'm the deployment controller.
Only interested in deployments.
Right. Exactly. And now, another thing behind the scenes is the replication controller, which I'm going to put another hat on, which is also doing this reconciliation loop. And it's going to say, hey, Eric, do you have anything that's a replica set?
Yeah, I have.
Oh, well, you do need that.
Yes.
Yeah.
That's a new replica set that was created before. It could have been created by a user, but it happened to be created by the deployment controller. But that's exactly the same thing, right? And it's going to turn into the same effect. So yes, I do have one.
So you do have a replica set. And as a replication controller, my job is to make sure that the number of pod resources are there based on the number of replicas. So here we have 2 replicas of Nginx. And so my job is to say, oh, actually, Eric, do I have any pods that's for this? Do I have any Nginx pods right now? No?
Not yet. Apparently, no. There are actually no pods for Nginx.
So if there are no pods, then as a replication controller, I'm responsible to create the resources here. So I will then create 2 more resources, 2 more pod documents, and I'll hand it back to Eric as well.
So we decided to tear a sheet of paper in 2 parts, right? You remember?
Yeah.
So what should I do with the phone?
Don't tear the phone, please. Yeah.
Okay.
Keep the phone in one piece. Yeah.
Okay.
So now we have 2 pods, but these are just resources. These are just documents. At this time, nothing has been created. Nothing is actually running in Kubernetes, right? And then finally, I put on another hat, which is a scheduler. Oh, at the same time, deployment controller is still asking Eric, do I have a deployment? No.
No.
All right. And as a scheduler, I'll be asking, do I have any pod that's unassigned? Do I have any pods that is not scheduled to anywhere?
You do. 2 of them.
Yeah, and 2 of them. I'm going to go through my heuristics. I'm going to figure out where to deploy these pods. And rather than going to the machine and deploying them, all I'm going to do is to write in the document and say, pod number 1, you're going to go to node 1, and pod number 2, you're going to node 2. And then I push back the document back to Eric, back to the master node. And that's it. And then finally, the thing that actually schedules the actual container onto Kubernetes is the kubelet. So there will be multiple kubelets. There will be a kubelet running on each node. So I'm the kubelet for node 1. Then the question I ask Eric will be, hey, Eric, do you have anything of a pod that is scheduled to node name is node 1, which is me?
Node 1. Yes, I have one of those.
You got one of those, in which case I'll take that. And then it's my job to run in a loop to make sure that whatever that the scheduler told me to do is actually instantiated on the node, right? So through this process, we are able to push a document into Kubernetes. Controllers will take care of all the subsequent steps. and then all of the data exchange are happening with these resources. If you think about Kubernetes, this is what I kind of think about it myself, which is I don't know if anyone here have used or deal with a traditional ERP system or a content management system, where you basically say, hey, I need to order 5 widgets, and then somebody behind the scenes is physically responsible for making sure that 5 widgets get shipped into your warehouse. In those cases, it's a physical person behind the scenes doing it for you. But here, it's really just document passing along, but not to a person, but to controllers.
Yeah,
really.
Not only that, and we see also that there are kind of lower level abstractions and higher level abstractions, right?
Yep.
So, and everything builds on top of the other. So that's very important because that's the way the Kubernetes ecosystem works in a way. And we'll see that's how Knative works.
Yep. And that is also why pod is the atomic unit that Kubernetes can schedule, incidentally, right? Because the pod is what the kubelet is actually looking for. All right, cool. So we covered that. But what is really nice about Kubernetes is that if there are things that doesn't help you describe what it is that you want to deploy, then you can actually write your own resources. You can extend the functionality of Kubernetes by writing your own resource and your own controller.
But there is only deployments and replica sets and stuff like that. How can I write new stuff?
Yeah, so the way that you can do it is by using a custom resource definition. This is the primary way to extend what Kubernetes can do. So for example, one of my colleagues, his name is Mark Mandel, he created this project called Agonist. Agonist is a project that's designed to run and operate game servers. So if you think about playing games, and there's always a backend somewhere, the way that you schedule the backend game servers are very different from how you want to schedule a regular stateless application. That is because game servers need to have low latencies between the players in the game, and so there are different ways for them to take care of that. And so for Agonist, what they have done is to write a custom resource definition to define something called the game server. And with that, you can also use the OpenAPI v3 spec to define what payload goes into this particular this particular object, right? This like the properties and what can go into the values and stuff like that, right? Mm-hmm. And then you can write the game server.
Okay, so if I got that right, I created a resource of type custom resource definition.
Right.
And now that gives me the ability to create a new document with kind game server,
with
right?
Kind game server, correct.
Excellent. Yep. And so each resource is defining its own group, kind, and version, I guess. So we can version that. And in the spec, I would put whatever I want according to the validation, obviously. Yep. But then we can store that. But it's only stored then, right?
Yeah.
What do I need to do with that? Oh, I need to write a controller. The same way there was a deployment controller or a replica set controller. Excellent. OK, so you would write a controller that continuously monitors those custom resources, so game server in that example, and would react to changes to that. And it will look at the spec, look at the current status of the system, and reconcile them. And maybe it's going to create deployments for that. And deployments would, in turn, create replica sets, as we saw previously, and so on and so forth, and pods.
Huh, interesting. So you can actually extend Kubernetes to have any resource you want, right?
I guess so, yeah.
Yeah, so if I don't want to play games, if you want beer? Beer? Can you create a beer resource?
Sure, as long as you create a custom resource definition for beer.
Okay.
Then, and have a controller that does something. Maybe go order some beer online. Then you could have a beer custom resource definition.
Yeah. And then you can use the API to control a little robot that can pick up the beer and put it in the fridge?
I mean, anything you can think of. If you can write code for it, a controller for it, you can do it.
You can do it. Oh, that's very cool. So you can store any arbitrary data that's being validated, and then your controller can can react based on that, however it wants.
And that's the way you expect things to work in Kubernetes.
Yeah.
And so remember that term, custom resource definition. You'll hear it throughout. Maybe CRD is what we're going to use. Okay. Excellent.
Yeah. So let's move into Knative and how this relates to what we just talked about, right?
Okay. I was here 3 years ago, and I went to your talk, and you presented Kubernetes, and it was all great. You told us Welcome. You told us about how you write code, and you can create a Docker image with your code and push it to a registry, and then create a deployment document, as we saw earlier, and push that to Kubernetes. It's going to grab the image and then expose it to the internet. You then set up your HTTP load balancer, and you can scale manually the deployment to several instances. That was pretty impressive. It's really cool. But then I wondered, I'm a developer, and part of that I don't really care about.
Oh.
I want to focus on writing code and deploying it.
I suppose, yeah. I mean, at the time, that was probably one of the coolest things that people have seen, the way that we use Kubernetes to manage and deploy apps, right? I had done presentations in the past where some people really almost bursting into tears to see how Kubernetes simplifies a lot of these steps. But now, I guess we have to deal with more steps in a different way, right?
Yes. So what if I just want to write code and see it deployed?
Right. Yep. So luckily, there's a way to do exactly just that. And that is by using the CRDs, right? And by using the Kubernetes concepts, that we can actually build these higher level abstractions that only deals with, we can basically abstract away all of these other things and collapse them into maybe just 2 steps, or maybe even just 1 step in that case. And that allows us to deal with our applications at a higher level. Just like Kubernetes is dealing with infrastructures at a higher level, we need something that can deal with application development and deployment at a higher level as well. And that is what Knative do, and that is where Knative comes in. It is a Kubernetes-based, so everything in Knative is running on top of Kubernetes. It is a building block, so it's Kubernetes-based building blocks for serverless workload. And when I say serverless here, I don't particularly mean functions, right? Serverless has so many different meanings, and obviously you saw that I have a couple of servers behind the scenes, right? But in this case, when we talk about serverless workload, I think I'm talking about workload that can be elastically scaled up and down, that can run for a short time if necessary, and we can scale this down to 0 if we want. So Knative offers the building blocks for platforms to build this type of system so that you can deploy your app in a serverless environment that behaves like a serverless application. And the way that it does it is through introducing some more primitives that's native to Knative, but it's built on top of the Kubernetes CRDs. So the primitives we're talking about is the build for how do you want to build your application. Serving is how you want to serve it. And eventing is where how the messages can be exchanged synchronously between the different functions or between different applications. It is an open source project that was originally created by Google, but with also a lot of contributions from great partners like Pivotal, of course.
Certainly.
Yeah. And the way that the architecture looks like is that, well, underneath of everything, of course, we have the Kubernetes cluster, which we already provisioned, right? So that allows us to do the deployment, the replica set, and the CRDs. For networking, for the L7 type of request, so when you're making a request, we're sending everything through our service mesh. So whenever you do a HTTP request, it actually gets routed through a service mesh, which allows us to have a uniform way to handle cross-cutting concerns. So this will allow us to do routing, will allow us to do retries, circuit breaking, and all of those things without actually having the function or the application implementing those specific functions. And then finally, on top of that, Knative introduces 3 different CRDs and a little bit more, but primarily 3 of them, which is serving, build, and events. Okay? And so that's what cannot make Knative to be Kubernetes native, mostly because of the fact that it's built on top of the native constructs of Kubernetes, specifically with the CRDs and the controller patterns that's being implemented.
And so I could continue to interact with my cluster with the tools I know, etc., right? Like kubectl, all of that.
Right.
Cool.
Yeah.
OK. Let me talk a bit about Riff then, which happens to be built on top of that. So what we say often is that Knative is a platform for platforms. So as a user, you wouldn't necessarily interact with Knative directly, but it's interesting, I guess, to understand how it's behaving. You would typically interact with a higher level tool, of which Riff, which stands Riff is for functions, is one example. So it's a function as a service platform that's started before Knative existed, but was repurposed on top of it. I'll talk about it later. And it's a very narrow-focused, opinionated way to run functions on top of Knative and Kubernetes, so in a native way runs native containers there. And it comes from the pivotal team, the Spring team, so a lot of people who were involved in Spring integration and Spring Cloud Data Flow in there. And so it allows you to focus on your function code, so the business logic of your function. Whatever the language, it supports different languages, and you write your functions in a very idiomatic way to that language. So if you're writing Java, for example, you would write something that does implement java.util.function. And what Riff does is it turns it into something that Knative can understand. And as I said, the project started on Kubernetes more than 1 year ago, but at the time, Knative wasn't even a thing. And so we partnered with Google early in the Knative development lifecycle, and some of the concepts that we had in Riff, namely the topics abstraction and the transport layer, the bus layer, actually became things that you can find in Knative today. So when we talk about eventing and the channels concept, the bus concepts, that's coming from the Riff. So is the concept of building, which was happening locally in Riff previously. Here we are now leveraging the build and build templates concept from Knative. And then what's still left as a, I would say, custom offering on top of that is the CLI that I used previously, and that concept of an invoker, which is specific to Riff and decides how you turn some function written in some language into a specific application on Knative, and it has very strong opinions there that, for example, it doesn't want your function to be tied to Riff at all. It's written in an idiomatic way, and you just turn it into an app. So when we talk about Knative and Riff and all of that, I guess we can focus on different audiences for that. And as I said previously, you don't really necessarily mean to deal with Knative directly. But I guess it's interesting to understand the underlying concepts. You would typically interact with something such as Riff, or even through the API of Riff. So let's talk about the first building block of serving.
Yeah, definitely. So let me just check the time, and yeah, I think we're pretty good. So with Knative serving, it basically allows you to create and deploy your application, whether it's a container or directly from source potentially, into the Kubernetes cluster. But then behind the scenes, we also take care of a lot of other things like creating the network services and creating a L7 load balancer, and then creating the routing rules behind the scenes. And that whenever you deploy an application, we want to make sure that we keep different revisions of your app behind the scenes so that you can go back to the revisions if you want. And that is what we call almost a point-in-time snapshot, which is a combination of the specific container revision that you deployed, in addition with configuration that you associate with that particular deployment. So it's the binary and also the environmental variables and any of the other configuration that you associate to that particular instance of the app. So I guess we can go ahead and take a quick look at it. So the way that we're going to deploy something into Knative is to, with Knative, because these are the building blocks of the future, say, serverless platforms, you can still write a lot of these things directly with, say, a YAML file or a JSON file, or however you write your Kubernetes resources. So it defines a high-level concept called the serving, or the service in serving. And if I go to one of these things, let me see here, image deploy.
So service is a new custom resource defined by Knative, right?
Yeah.
Not to be confused with the Kubernetes service. So there are, sometimes we'll talk about both. It's a Knative service.
So it's Knative service. It's not Kubernetes service. It's also not Istio service, if that makes sense. Yeah, it's its own service. Why do they always come up with the same name?
Don't ask me.
All right, fair enough. So here's the one way to create a new service here. So Kubernetes Knative service, KSVC. All right, so here's the new service. I'm going to create something called greeting, and then I'm going to potentially deploy this directly from an image. And I can also just create this this application right now if I want. So why don't I give that a try? So I'm going to do something pretty simple and pretty quickly here. I'm just going to go to Spring Initializer. I'm going to create a regular web application. I'm going to use Kotlin for it just because it's pretty simple and straightforward and fun. And I'm going to code this the greeting service. I'm going to go ahead and create it, right? And what we're going to do is to just quickly create this service, this application. Again, it's not a function. It's really just a regular app that will serve through an endpoint. And then we're going to turn this into a container image, and then we're going to just deploy it, right? So the way I'm going to do that is by, if this IntelliJ thing would ever open up, there we go. And I need to wait for this whole thing to synchronize. Yeah, there we go. And then I can go ahead and zoom in a little bit here. I'm going to go to my app. There we go. All right. And, oh, I don't want to debug. Yeah, never.
No bugs.
No bugs. Yeah. No, exactly. So I think the reason why there's no bugs is because I have a template for it.
Oh, that's OK.
So magically, code just appear. It would be awesome if we can do this with everything that we ever do. All right, there we go. So I'm going to use the configuration here with the add value, so we can take in the greeting from a environment variable. And then here we're going to do a post mapping. We can do get. We can do whatever we want. But just to interrupt with some of the other things later, we're going to do post. And then we're going to get the name from the request body. Again, you can do parameters if you want to, whatever. And then we're going to print out the logger in info, and then we're going to return the greeting, which is based on this value, which will default to hello, and we're going to say hello to Ray. So it's a very, very simple app. Now, first thing I need to do is to potentially turn this into a Kubernetes, into a container image, right?
So you're going to write a Docker file.
Oh, no. Well, you can if you want to. Yeah, sure. But we have an easier way to do that today, which is by using something called Jib. So if you are dealing with containers today, if you want to create a new container image, of course, you can write the Docker file. You can use like Maven Spotify, like the Spotify Maven plugin and stuff like that. But Jib is an open source project coming from Google, which allows me to build a Docker image or a container image without actually having Docker daemons installed locally. So for example, I can go ahead and create this new image with the GCR.io. I'm going to put in my coordinate here. If I remember, it's Knative Riff demo. And I'm going to code this greeting Devoxx, right? Just so I use a different name, maybe. All right, there we go. And then I can go ahead and compile and install this, right? So let me try it. So here's my download directory. We have nothing. And here's my greeting application, which I have. I'm going to be adventurous and just going to go ahead and compile it. And then if I want to turn this into a container image, I just need to do jib build. What this will do behind the scenes is to examine the build file that you have, so the POM or the Gradle file, and understand what it is you're trying to build into a jar. But rather than building a jar, oh, sorry, I need to set my shell to 1.8, just because that's the one that works best. All right? And then I'm going to export my Java home again. Whew, demo fail.
Authentication error as well with your registry.
Yeah.
If it's
no, that's fine. Yeah.
Okay.
Yeah. So what happened is that I was running OpenJDK 11 that doesn't have all of the necessary credentials for SSL. So it doesn't have all the SSL certificates that it needs to use to validate. So now with Java, I switch back to my old JDK. Now I have all the right certificates, my CA. So anyways, so what Jib will do is to analyze. So rather than building the jar, it's going to see, oh, you have some dependency you need to add. So Jib will automatically and smartly add that into its own independent layer. And then all the class, because these dependencies don't always change, right? And then we will build all the classes into a separate layer and the resources into a separate layer. And then Jib will actually push these layers independently from each other directly into the registry. And now we have a container, just like that. And once you have the container, then you can go ahead and run it in one of these YAML, using the YAML file descriptors. So I'm going to copy this out to, say, devoxx.yaml. So let me go ahead and edit this file. There we go. So here we have the kind which service. This is a CRD, right? Defined by a CRD. And then we're always going to run the latest version of whatever I'm going to deploy. And then here I can specify the name of the container, which is I'm going to change it to the one I just built. Of course, here we can have the environment variable. I'm going to say hello by default. And then we can also add in the readiness probe and the liveness probe if we want to. This will help with, just like Kubernetes, this will help determine whether your application is ready to serve. Now, watch very carefully. Once I deploy this, I'm going to say apply app Devoxx YAML. If everything works, it did work. Well, it's not finished yet, but hopefully everything works. It's going to go ahead and deploy my application. And as you can see here, this is an interesting bit. When I deploy this app through Knative, rather than having one container that's ready, we actually have three.
Three, but your app is just one container.
Exactly. I just have one container for my app, but I have three. Why is that?
What are the other two?
Yeah, well, let's take a look. So what's the best way to kind of look at what's there? So I'm going to do just a log. So I'm going to say logs. Without help me to see. So what happened here is that it's going to ask me, oh, wait a second. I got,
several containers.
I need to specify one. Yeah, exactly. So as you can see here, what Knative did is that they put my application container into the user container, right? Because in Kubernetes, we're dealing with pods, and a single pod can have multiple containers running inside of it. So here we have the user container that's actually my app. And then we have the Istio proxy container. This is the one that allows us to intercept the request, and so that the request can be forwarded to the service mesh, and then we can do all the routing and traffic routing and the circuit breaking and the retries. So all of those are going to be handled through the Istio proxy.
Yep.
And then we also have the Q proxy, which is something that's specific to Knative. I think that's the one that's...
it captures traffic, and it sees that, hey, there is some incoming request for it, and then it can reroute it elsewhere.
I see. Yep. So, but in addition to that, what we also created behind the scenes is actually a route, right? So here we just deployed the greeting service, but now we have a greeting route. And what the route is doing behind the scenes is basically allowing us to look at, let me see here, greeting, yeah. What the route is doing is to allow us to say, how am I going to reach this service? So we have a fully qualified host name that we need to use. And then it also allows us to route traffic to a specific revision of that service. In this case, we only have one first revision, which is 0001, and so 100% of the traffic is going to be routed there.
Okay, so when you say route, it's, again, a Knative CRD concept.
That's right, yep. Cool. And behind the scenes, it can be configuring other things behind the scenes. So specifically, the route actually configures something called the virtual service behind the scenes. Once I configure it properly, it will be there. And then and that is the Istio virtual service that allows us to do the traffic routing and stuff like that. Yeah. And what else did it create? It also created something called configuration, right? So based on that service definition, it created the configuration. And if I open up the configuration, we'll see what's actually inside. So I'm going to say greeting and OYAML, and I'm going to do a less. So configuration is really just one of the blocks in service, where the configuration is really just the name of the container image and the values associated with this particular deployment. Now, every time I change the configuration, or every time I change the service and it changes the configuration, it's going to change the revision as well. So here we have just one revision. So if I want to change my configuration, then I'll have multiple revisions.
Yeah, it's going to create a new revision, because revision is immutable, as a matter of fact, whereas configuration is mutable.
It's mutable. So every time you mutate the configuration, we'll create a snapshot of an immutable revision.
That's captured in the revision. Yes.
Yeah. Cool. So let's give it a try, and let's try to hit this service right now through Knative. Now, we need an external IP address for this, and that's already configured for us through Istio. So if I go to get my Kubernetes service in the namespace of Istio system, because that's where Istio is being installed, and if I just grep for ingress, there will be an ingress for Knative, and that is the Knative ingress gateway, and that one has an IP address. And we can go ahead and try to hit this URL directly. So typically, you would imagine you can just hit this thing and then post your data to it, and it will go to the right application. But because we have multiple functions and multiple services running, we really have to qualify it with the host name as well, right? So what that means is we need to add a host header here manually. And the host header that uniquely identifies this application is something that we saw in the route, which is that one. So we can do that. Yep. And then we can specify the content type, which we're kind of expecting text plan. Is that right? Text plan?
It is.
Yeah. And then I'm going to say hello to, let's say hello to you, Eric. Did I miss anything?
I think we're good.
Yeah? How many people think this will just work? Oh, nobody. Wow, thanks. Well, tough crowd. One person, thank you very much. There we go. Well, let me format this just slightly better. So I'm going to say with WN, and then I can say, hello, Eric. That's pretty cool.
Hello.
Yeah, hello, hello.
But I'm French.
Oh, good point. So in that case, I need to go ahead and change my greeting. So rather than hello, I'm going to go ahead and change this to, is that how you say it? Bonjour?
Absolutely, bonjour.
Yeah. Bonjour, there we go. So now watch very carefully. I'm going to go ahead and apply this configuration. And what this will do, remember, it applies the service, updates the configuration, and now it creates a new revision. And based on that revision, we have a new instance of the app running. Okay? So if we go back here and say get revisions, we can actually see now there are two, and one of them is configured with hello, and the other one is configured with bonjour, right? So we can wait for this to start, right? What is this? It's a Spring app, yeah? It should start pretty quickly, no? Tell you what, I think I know what happened. So I'm gonna go ahead and delete this. Well, you know what happened? Because I modified the wrong one. So what I'm going to need to do is to basically update this one and update this to bonjour. So I updated the wrong file. Yeah.
Copy the file. Yeah.
Yeah. So let me try this one again. So ideally, this will also work. If not, we'll restart from beginning with system install, right?
Oh no.
No. Okay. So now we just the previous revision is probably bad. It will never probably start. So I'm going to start a third revision here. That will have the right readiness check in place. Can I delete a revision? Can I say delete my revision?
You can, but given that it's service, I feel that it's going to come back.
Yeah, it might come back. OK. Yeah, so now we have 3 revisions, and now we point into the latest one. And then if I go ahead and get the route, and check this out, this is pretty cool. If I see the greeting route, we can see very clearly now the route is also being scheduled to route to revision number 3 as well, right? So now if I do the curl post again, let me see curl post. Is that the one?
Sounds good. Yeah.
Yeah, maybe. Yeah. Okay. So now we see the new configuration, right? So as you can see, revisions are just a snapshot in time of your container image and also the configuration with it. We can also go ahead and say, for example, wait a second. Maybe I don't want to, maybe there's something wrong with the latest revision. I need to do a rollback. The way that you would do it is by changing the serving definition here. And then we can say, rather than using run latest, what we can do is we can say, well, I only want to run a specific revision name. So for example, if I want to reroute all the traffic back to 0001, right? So all I need to do is to say, rather than run latest, let's go back to pinged. I'm going to ping it to one of the revisions here. Okay, I'm going to save that, and then I'm going to apply it. Apply, there we go. Now, when I'm applying this, there's no change to the configuration. We're just changing the route. So again, if we go back to the route to see the greeting stuff, we can clearly see it went back to 001, and we can clearly see if we do another curl post, and it will say hello again.
That's really cool.
Yeah.
But OK, that's more than nothing, definitely. But when I do that in production, maybe I don't want to do an all or nothing switch, right? Maybe I want to gradually deploy my new version of the app, kind of a blue-green deployment stuff or canary style. Can I do that as well?
Yeah. So you can not only do blue-green, you can also do canary fairly easily with these higher level constructs. So the way that you would do it, let me go into blue-green here. What we need to do is to deconstruct the serving or the service definition, because when you define something in service, you only get to control whether you want to route traffic to the latest version or to a specific version. If you want to have more fine-grained control, then I guess I will have to kind of break this down into the underlying resources that it otherwise create. Yeah, go ahead.
So we're going to see the kind is configuration
right.
in Knative and I guess a route.
Yeah, and also the route. So in this case, we're going to deploy something that's already made, a blue-green example. And by default, we're going to start off with the blue version of it. So we're going to hopefully see the blue version. And here's the route. So a service will create both the configuration and the route for you. But in this case, we need to create these things ourselves, right?
Sure.
Yep. So let's go ahead and try this out. So I'm going to apply stage 1. And Knative is going to do its thing. Remember how this works behind the scenes. The custom resource is stored into Kubernetes. And then the controller, Knative controller, wakes up, and then it deploys everything for you, writes the right resources back to Kubernetes, and there we have the blue-green stuff. But we need to take a look at it. But so one thing we can do, of course, is to do the curl. So we can do a curl. And we can, of course, do host, and we can say bluegreen.default.example.com. Right? We can do all of these things. And then we're going to just get it directly from here, I guess.
Yeah.
Oh, OK. So I can see app 1, but I really want to see this on the browser.
OK. So you need to configure the mapping of the host to that IP address, right?
Right. So somehow we need to change the name of the domain name, right? So right now it's example.com. I would hate to configure my host file right there. So what we can do is to actually get CM. So Knative is also very configurable. You can configure a lot of the characteristics and behaviors directly from the config map. That is native to Kubernetes, of course. But so for example, the domain name that we want to serve from can be configured directly from the config domain config map that is living underneath a Knative serving namespace.
OK.
So for example, here, by default, we're going to configure this to go to example.com. But I can also configure it to the IP. And then I'm going to use the nip.io so that whatever domain name I use here is going to be resolving to the IP address that I want, right? So now if I go back to the route again, let's see if I get the route, get route.
Yep.
There we go. And if I see the domain name here, now rather than having example.com, which is what I need to pass every time I pass the request in the host header, now we can just do this directly from the browser because the browser will then pass the host header. Yeah, the host header alone. So why don't we go ahead and try this? So I'm going to go here. Oh, sorry. I'm going to copy and paste it. And let me go ahead and find my browser. I'm going to say blue-green default. Yeah, there we go. So actually, anybody here can also go to this site right now if you can remember all the digits, but it's there. And now if we do a refresh, we can see everything's going to blue.
The blue one.
Yeah.
Okay.
So of course, we can up this up. We can change the configuration here. So here I have a second configuration I want to apply. So maybe I need to update my configuration. So notice here the configuration name, the kindness configuration, the name is still blue-green.
So it's the same name. That's what's important. Different file, but when you're going to apply it, it's going to mutate that particular configuration that we had in step 1.
That's right. Yeah.
Okay.
And then it's going to, of course, create a new revision based on this configuration. And then for the route, here is where we can be creative. For blue-green, maybe we just want the new version to be there. We don't want any green version to be served. So we set that traffic for green to be 0%. But let me go ahead and apply this. What this will do is to create a second revision behind the scenes, right? But at the same time, there will be no traffic routed to it, right? That's because we've configured the route 100% to v1. Now we can go ahead and say, if you want to do canary, if you're not so sure how much traffic you want to send users to the new versions for, then you can configure the route with different traffic percentages. Yep. So here we can say revision name is blue-green 0001. That's going to take 50% of the traffic. And the new one is going to take 50%. And we can even give the route a name, a specific name, which will be very handy in a second. So let me go ahead and apply this. I'm going to apply the stage 3, which will update the route. And what happened behind the scenes then is that if I go to get route for blue-green, there we go, blue-green. We can clearly see that the route has been configured.
So if you go to the browser, you should get half of each, right?
Yeah. So hopefully, yeah, there we go. So 50, 50. So every time I do this, it was a 50-50 chance for me to hit one of them specifically, right? Because that's the probability we set. We can also remember the name that we set for the particular route for revision 2, which is v2. We can also go to the v2 route directly. And if I go to the v2 version directly, which via the URL, then all I'm going to see is v2.
So you would keep that a secret and be it a way for you to test before you actually roll it out to the public.
Yep.
Okay. Yep. Excellent.
So that's also pretty easy to do. And then finally, when you're ready to do the rollout, say, yep, the new version is perfectly fine. Then we can, of course, up the traffic to the new version if I want to. And now the new version becomes the default version, and so on and so forth. And you still have the old version that's ready to serve.
And you can give a name to the old version if you wish, so that you can go back knowing it, right? And it's there.
Yeah. So here's the name for the old version. So in case I do want to go back to the old version to see, to just keep it on my back pocket for people to try, I can. So now the primary version now is all green, right? All green. Yeah, pretty good. And then I can go to V1 if I want to just see if V1 is still working. Yeah. So that's pretty awesome, pretty straightforward in terms of how the routing stuff works. One thing also behind the scenes that we can take a look at is the virtual service. I think now we actually have a virtual service that's being created, and still not. I wonder where did that go?
Is it because it's not qualified to Istio?
Oh, that's probably it. Yeah. So there's going to be a Istio service behind the scenes that's actually implementing all these routing rules. That's how we actually get to the blue and green stuff. Yeah. But we'll find it later. Okay. Let's see. What else did we do? So let me just do a quick recap. And we started off at what time? 1:30?
1:30.
Yeah. So I think it's a perfect time for a
break after that, I guess.
After a little recap. So remember what happened behind the scenes. We created, using Kubernetes CRDs, we created a new CRD code service. And then as a user, I created a new service of the kind that's based on the definition. And then when I push the service into Kubernetes, a controller behind the scenes from Knative wakes up. And based on that service definition, that controller created the configuration. And the configuration is pushed back to the master.
Yes.
And another configuration controller wakes up, right? And then say, oh, did they make any change? If they did, go ahead and create a new revision. That's what happened. Yeah.
There were none at first, so it's creating the first one.
Yeah. And then we also created the route behind the scenes, right? So now the route is by default pointing to the revision. And of course, now you understand how Kubernetes works behind the scenes. When I created that revision has a controller behind the scenes that also created the deployment for me. And that's a Kubernetes deployment. It also created the Kubernetes service behind the scenes. And of course, the deployment creates a replica set. And the replica set creates the pod. And the kubelet gets it. And that is how we ended up with these pods running in our environment at this very moment. Okay? So just keep that in mind, the workflow that actually happens behind the scenes. And this is going to be very, very useful for the next 2 sections as well.
Yes.
Okay.
Same principle.
Yeah. So should we go ahead and take a little break? And this is 2:30 right now. And we'll come back at 2:40.
Yeah. 10 minutes break.
Okay. 10-minute break. All right. Thank you. Yeah. All right.
Back. Thank you for coming back to this session, and we'll continue with new components of Knative, specifically build and eventing. But before that, if you were there the hour before, we left with those virtual services which were missing, and I think we found them, right?
You found them?
Yeah. So they happen to be in a different namespace, so this is why we didn't see them.
Yeah, there it is.
So I think it's here, as you can see. And so I looked it up, but there is something weird. The host is dealing with activator-service Knative serving, and so I'm a bit confused. And also, my pods are gone.
So you found the virtual service, but you lost the pods. Is that what you're saying?
Yes, basically the pods are gone. Where are they?
Yeah, so wait a second. So we had the blue-green stuff, right? So we had blue-green.
Yeah.
So if I say KSVC, that's how I can see the Knative service. Do we now have Oh no, we didn't have. Yeah, so we have configuration.
Okay.
That is the blue-green, right? And then we have greetings and upper. So we deploy all of them. All of those things worked. And then we also found the virtual service here. Is that right? So what happened is that
I'm wondering if it still works, as a matter of fact, because the pod is gone.
Yeah.
I'm a bit worried.
You're a bit worried? Well, you shouldn't be. Well, so what happened behind the scenes is that, remember, this is a serverless building block. So what that means is we will scale out your application automatically based on latency and all that. But when nobody's using the app, we also scale it back down to 0. So
0 as in no pods?
As in no pods, yeah. That's why you're not seeing any pods, because all of them has been scaled back down to 0. If we were to revisit the deployment, for example, remember how this happens. Service configuration is revision to deployment, and deployment is
desired 0.
Yeah.
Okay.
However, to answer the question about the virtual service here, so remember, virtual service is something that the route creates on behalf of Knative, and the virtual service is a Istio virtual service, right? And this is directly responsible for actually receiving the traffic, which is that, right? And then routing it to a destination.
But that's not my app.
That is definitely not your app. So because we scale everything down to 0, there will be nothing to receive the traffic. And so what happens behind the scenes then is Kubernetes Knative will reassign the destination of this request to this thing called the activator.
So it's not going to work. It's not going to work. It's not my app.
Yeah, well, activator is there. It's always there. That will be there to receive any traffic that has no running pods behind the scenes. And it will actually forward the traffic onto the pod when I start it. So why don't we take a look at it? What am I going to do? I'm going to do a curl.
It's in the browser, I guess.
Yeah, we can do the browser. Or maybe we can do a get here as well. So maybe something like blue, green, default example, that one .nip.io. You're right, it's not going to work.
It's not.
No, just kidding. No, there it is, right? So what happened is that the activator received the request, and then it realizes there's nothing running behind the scenes, and then it automatically scale out my application. Now I have one instance running, and once this instance is up and running and ready, then the activator who received the request, who cached the request, will then forward the request onto the actual service.
So if I look at that.
Yeah. If you look at the virtual service again, it will eventually. Oh, no, that's because. There we go. There are multiple definitions. Is that right?
I don't think that's the one.
No. Oh, sorry. Yeah, you're right. So let me see here. Get virtual service. All namespaces. Yeah. And yeah, there's the blue-green. And let me see here. One of them was up. So
maybe it wasn't updated yet.
Yeah. I know why. Because there are remember, we actually split the traffic between the two. So this route actually went to version 2. So that is not activated anymore. If I trigger this enough time, so if I do the curl again, one of this time is going to go to green and one. Oh yeah, so sorry. We also, at the end of our last talk, we switched all the traffic to green. So that's why only the green one has it now. Yep. So that explains a lot of the things.
Indeed. The important stuff is you're saying my app works. So that's good.
Yeah.
And specifically during the break, I didn't pay for it because it was 0 pods, right?
That's correct.
No resources consumed.
Right, so no resources consumed. Yeah. If I want to kick off the blue, remember we had that name v1?
Absolutely.
Now we are kicking off blue, and we got the result back. And hopefully now if we go back to and get the virtual service, we can now see the destination itself.
Excellent.
Yeah. Okay.
Very good.
Ooh,
impressive.
Awesome. Yeah, not bad. Whew. Well, at least we found the virtual service and we found the pods.
Okay. So let's talk about something else now, specifically the build part, because you showed us how to push an image and everything. And at the beginning of the talk, I told you I just want to write code.
Right.
So I'm wondering how I can do that.
Right. So
Knative has a component, part of it, named build. And this is the definition you find on the README page. And I'll let you read through it. But basically what it allows is to run any kind of step that you can abstract away in an image, succession of steps in a workflow, as long as they can tell whether or not they succeeded. And you can do pretty much anything with that. Typically, what you would do is to use it to build your app from source. So grab the source of your app, run a series of steps, and at the end of the day, create and publish an image. So the way this works is, again, through a series of custom resource definitions, so new concepts introduced in Kubernetes that didn't exist before in the Knative group. The first one is a build. So a build is really an instance of that workflow running, right? Like taking some steps and run what they call builders. And you can do pretty much anything. But you wouldn't create a build instance manually, definitely not through YAML. What you would do is to create kind of a recipe for it. That's what a build template is. So again, a new CRD, which is called a build template, where you specify the steps, but obviously you don't know what you want to build at that time. So you would have that concept of some variables in there, placeholders that you don't know the value for at the time, and you create that in a build template, and then when you want to use it, you would tell the system to use that template with those particular values. And this, in turn, will create a build with the values. And this is all just fine, but typically when you do builds, you need to grab source from let's say, a Git repository, so you need to authenticate against that. Or if you create an image and you want to push it to a registry, chances are that you need credentials to be able to push to that registry. So all of that also works with hand in hand with the concept of service accounts from Kubernetes. And you can specify which account to use, where you would have put specific secrets in a specific form there so that they know how to authenticate with remote resources like a Git repository or a Docker repository, Docker registry. And so this is a new concept introduced by Knative, and you can create your own build template, but it turns out that Knative already provides some of them. So if you go to the Knative repository in the Knative org build templates repository, you can see that there is one for Bazel, Builder, BuildKit, and Kaneko, which is building via a Docker file, and I see Jib. Here, and we used Jib before, right? So you were using Jib to build the image locally. I wonder if we could maybe do the same thing, but running on the cluster.
Yeah. So we can go ahead and take a quick look at what this might look like. So here's the same repository with different build templates.
Yes.
And we can actually open one up and see what actually happens behind the scenes. The way that you deploy one of these templates is by simply kubectl apply it. Remember, this is just a resource in Kubernetes.
Yeah, so if we look it up, its kind is build template. So it's the CRD introduced by Knative.
Yeah. And this particular build template name is called Jib Maven. And then here are the parameters that we can use. So the name of the image, we want to build to. The directory of the source code, the subdirectory in case you have multiple modules, and then we can even do caching. So rather than downloading the Maven artifacts over and over and over again, we can cache it to a persistent value in Kubernetes as well. And then here are the steps,
And so there is only one step, and what it does actually is run Maven, right? When you see the image, it obviously talks about Maven, and we see the args, they look familiar. There are Maven arguments, and they're passing the values there. Okay.
Yeah. So you can have potentially multiple steps here, but here is very straightforward. We only have one step. And everything you need to run in the step, you mentioned earlier, you have to capture that in the in a container, right?
Yes.
Yeah. So this Maven container actually has Maven pre-installed with the JDK and all that, so that we can actually perform this step. So we can go ahead and just install this new template, for example.
Yeah. And I should mention the contract with build is that, if you go back there, is that the app you get. So there will be another step, step added before for you, which checks out the code, and the contents of that repository is made available under /workspace. That's basically the contract.
So that's like an implicit step before this one.
Yes,
basically.
You'll see there are 3 steps.
Fantastic. So let's go ahead and put this build template here. So how many people use Maven here? Maven? Okay, overwhelmingly most of the room. Very nice. Gradle? Some people. Yeah, so if you're using Gradle, we also have a build template for Gradle. And there's always one or two. No? Yeah, there we go. Yeah. But sorry, we don't have a build template for that. But you can write one based on the build template here, basically, right? So anyways, so we're going to go ahead and deploy this. So I'm going to, remember, we have a cluster that's brand new. So we're going to have to do this right now. So this just created the build template into my Kubernetes cluster. So get build template. Yeah, there it is. There's the jib maven one. And then we can go ahead and deploy from source, actually. So rather than doing all the build locally on my machine, if you have code, we can just deploy it directly with the Git URL that you have access to. So we have some choices here. We can, with the jib maven build template, we can literally deploy any Java application that serves on port 8080 that has, that can be built into a jar or something like that. So I don't know. There are a few popular ones.
Yeah, I can think of, let's say, Pet Clinic.
There's Pet Clinic, yeah. So we can deploy Pet Clinic if we want to. Or we can do, we got tons of examples in Spring Boot, right? So we can deploy pretty much anything that's there.
So what we need is a POM file, and that's it. Because it's going to request the jib plugin anyway, even if I don't have it in my POM file, right?
That's correct, yeah.
Okay, so anything should work.
Yeah, and that is because here, when we run this command line, this is a fully qualified plugin name. And so even if you don't have it in the POM, it will still download the plugin and run the plugin itself. So I don't know, how many people here want to see something from Spring Boot samples? Some people. How many people want to see Pet Clinic directly from Spring Pet Clinic? Oh, nobody.
Pet Clinic is over, man.
Oh, my goodness. OK. So in which case, lucky for me.
Let's do Pet Clinic.
Lucky for me. Yeah, exactly. We'll do things that people don't want to see. Yeah. So I'm going to show you how this works. So I'm going to go to the Spring Boot repository here. And we have tons of samples here. Now, it is a big repository, so the checkout time might be taking a while. And I think there's something with the Webflux here, right? So we can do Webflux. That's pretty popular. Yeah, fashionable, exactly. There are a few of them here that we can use, if they're still here, I hope. So, but anything that we find here will be able to build. We can also build from a particular revision based on the name of the branch or the tag and stuff like that. I think I have this configured up. So basically what you do is to copy and paste the repository URL, which I have down here. So that's right here. So we have Spring Projects and Spring Boot. And then I'm going to build directly from the tag a v210.
Could be master, right?
It could be master, sure. Yeah. But things on master changes constantly. So I'm crossing my fingers. Nobody touched the tag, right? And then we have the directory. So this is called the Spring Boot sample webflux. So hopefully that's there, sample webflux. Yeah, there it is. So that's the webflux example. This will probably serve something on port 8080. And let's see what this actually do. Something that says hello. Yeah, hello world. Something pretty simple and straightforward, whatever. Okay. Yep. And then we can specify the name of the image. So that's the name of the image I want to build into.
And wait, what's that funny ampersand image thing?
It's like one of those C++ pointers, no?
No, I think it's YAML syntax, as a matter of fact.
It's a YAML syntax, really?
Yes, it's declaring a label in case you want to use it later in the document.
Ah, so it's like a temporary variable that you can define, or?
You could see it that way.
Okay.
Yeah.
So like this value will then be stored into the image thing.
Yes.
Okay. And then we made.
Oh, then that's a reference to a pointer.
Ah. Yeah, and then you have the reference to the pointer.
Yeah. Basically.
Yeah. So that defines the pointer, and that's the reference to the pointer.
Anyway.
Yeah. And maybe we use the cache, or maybe we don't. Let's give it a try. So in order to use the cache, if we want to do it, we'll provision the cache here. The cache might take a minute to provision, so maybe we don't use the cache right now. So what we're going to do is
we're going to build once. Anyway.
Yeah. Unless if it doesn't work, then we have to build them up.
Oh, that's true.
So why don't we get rid of the stuff here? So we're just going to build it once, so we're not going to use the cache. And one more thing that's really important. In addition to the source and the template that's going to be passed into jib, there's this thing on the top, the service account name.
Yes, and so just to clarify as well, right? Yep. Here we're defining a Knative service, right? Yeah. And so before we had a reference to some image locations. And I see what you changed here is to use build, right? And build and the name template. So what you're saying is that we're going to build create the service, but using a build. Oh, interesting. So I know that Knative has several components, and the build stuff is totally optional. You don't need to use it in serving. And on the other hand, you could also use build on its own and use it to build stuff, but they can interact together, and that's where it comes handy, I guess.
Yeah. And so the service account here is really the credential that's required to be able to push the container image into my private registry, right?
Yes, which we configured.
And then the template here refers to the Git Maven template, which I just pushed into Kubernetes. Yeah. So with any luck, we should be able to deploy this. So let's go ahead and try it, Pet Clinic.
And we'll take the logs.
Yeah, so to see the logs, I can use this utility you can find online. It's called logs.
So it's creating, running some init containers there.
Yeah.
And I see there are 3 of them, and it's already at step 2. So we saw that the Jib build template used 1 step.
Yep.
And I told you that there are going to be 2 more.
Okay.
They're provided by Knative without you needing to ask for them.
I see.
And definitely one of them is to clone the repository and grab the source and put it into /workspace, as we said. And so it seems that it is working. It cloned the repository, and now it's running Maven. And it's downloading half the internet.
Well, happily, it's downloading half the internet from the server, so we can, surely, and this will actually work because we're not depending on the Wi-Fi here. I think. Yeah,
absolutely. Not only that, and so we skipped the cache part. But if you were to configure it properly, and then you did a subsequent build, then it would reuse that volume that you mount, and so it wouldn't re-download everything.
So it occurs to me that using the Spring Boot repository is probably not the best idea, because it's actually compiling Spring Boot right now, isn't it?
No, it's not. But it's
no.
It's grabbing. It's grabbing all the
it's grabbing a lot of stuff. Yeah. So eventually this will actually finish, and at the end of this step, Maven will just triggering the compile, and then it's going to call Git build, and then it's with the right credentials, you should be able to push everything up to the thing. Now, one interesting here is that for every one of these builds, you can actually specify a timeout. So sometimes you don't want the build to take forever. Maybe that actually is the indication of something that went wrong. Or maybe we're not caching properly, or things like that, in like this case.
Maybe that's what we're doing.
So we can actually, if I go back to the example here, let me zoom in. If I open up the petclinic.yaml, the other thing that we can set is the timeout. So if you don't want this thing to go on forever, we have a timeout of 10 minutes. So maybe it will take 10 minutes to build this. No.
Actually, it's done.
Yeah. So after it downloaded the internet, or half of it, it actually went through and created the container image and pushed it, and hopefully also deployed it. There it is. So there's the Git deployment. And now we also have the route. And the route is going to default to petclinic as well. But let's just make sure this is up and running, so we can use like Stern or Kel to kind of see what's inside. So we can see the logs from this particular image. So we can say user container, something like that. There we go. So it is up and running in 10 seconds, which is pretty decent. And then we can go to, what was that, blue-green, right? Oops, sorry, blue-green. And we can change the route. By default, this will be defaulted to petclinic, which is the name of the service that we created. And crossing my fingers. Oh, wait. This is not petclinics. Wait, did I deploy the wrong one? I did deploy the wrong one. So I did deploy petclinic afterwards.
I told you we would deploy petclinic.
That was a subliminal message that I just got.
Yeah, we forgot to change it.
Yeah, but that's OK. So for example, if I want to, I can also go and deploy the YAML file for this one as well, right? So we can see how this actually works out pretty well, right? So you can literally deploy any existing application that is off of the internet today that's actually listening.
I told you type too fast.
Yeah.
I did tell you that, right?
You did tell me, yeah, exactly. I did the kubectl apply with the thing very, very quickly, didn't I? So let me just make sure I got the route. There we go. what was it called? Pet clinic?
Yeah. Oh, yeah. We did see it building, nevertheless. So I think that's the point.
Yeah, exactly.
Cool. It is there.
So there we go. That should be it. Voila. Oh, that's not bad. Yeah. So we have the whole thing running. If you want to see Webflux, we'll come back later because it is building now, and eventually it will also be deployed, and then we can go to the URL and just go from there.
Sure.
Yeah.
Okay.
Oh, cool.
So that's how Knative build works, and it's pretty important to platforms that come on top. And as a matter of fact, this is how Riff builds on top of that. So previously, I showed you a simple function, and we are going to go through that again. Here, for example, I have a very simple JavaScript function called square. It's used to square numbers. We love that. And we're going to run that and see exactly what's happening behind the scene. So I have the source for that function already. So let's say, look it up from maybe here.
So it's also in the project Riff samples. Everything's
yes,
here.
You can definitely look it up. So here it is.
And there's a square function.
Slightly modified version that logs, but it's basically it.
Okay.
So let me copy paste, or copy for now, that location. And I'm going to do Riff function create. Give it a name. So let's say square. Give it the coordinates to that repo we had just now. Give it the entry point to that function. So that's what Riff calls the artifact. And so it's going to be square.js. And use some image in Ray's repo.
It's the GCP project. Yeah.
Yep.
Yeah, you got it.
And let's call it, I don't know, square Devoxx. And for good measure, I'll add the variables flag, right? Sorry, what? Yes, that's what we do in France. Thank you very much.
He's using my keyboard, so
okay, I think we're good. So when I press enter, I'd like you to have a look at the bottom part of the screen and also the top part. But you'll see the steps. Previously, we used Jib. There were 3 steps. Here, you'll see that there are a bit more, and I'll explain why just after that. So it's cloning the repository. Again, this is actually creating, just to make things clear, this is creating a Knative service, which itself contains a revision and a route. So it's also creating a new configuration and route. Sorry, so it's creating a revision, grabbing the name of that. But here, because we also specify a build subsection instead of pointing directly to a built image, it's using everything we saw previously with the Jib stuff. And so you can see there are 8 steps. It's already at step 6 out of 8. You see pretty colors here. This is using the build pack thing. So the build pack is a concept that Heroku created that is also used on many other platforms, including Cloud Foundry. And the v3 version of those build packs allow you to use layers of the built image in a very smart way, so that you don't need to rebuild stuff that's not changing. So we'll talk about that. And so it ran. It created the image and pushed that to the repository. And now the deployment for it is created. You can see it's initializing 3 containers again, the app and Istio and the Q proxy, and now it is running. So I could invoke it, obviously, with a Riff. It's called Square. Let's give it some, let's say, JSON input.
So I guess previously I had to do the curl myself. So I did the curl, I look up the URLs and all that. Wow.
Yeah, so what Riff service invoke does is that it simplifies that for you, and it prints, it's actually using curl. So it prints the curl thing that it does, and you see 49 is our magic number here. So let's look at what happened, right? What we got is indeed, we got a, so when I say KSVC, it stands for Knative service, not to be confused with a Kubernetes service. So we did create a Square, the Square service, and that has a build section, right? So if we look at it in detail, you can see that it is a service. And it's using run latest for now, but we're using the build stuff, and we're referencing the Riff-CNB, stands for Cloud Native Build Pack, build template. So that's the name of the build template. Ray used Jib previously. We're using this one, which we registered when, at the very beginning of this talk, when I did Riff's namespace init. One of the things it did was to install that. And so you can see that some of the values I put in the command line, like the coordinates of the image I want or the artifact, they can be found here, right? And so this is what I have in my service. And if I have a look at the template itself, we can see how it is a bit more involved than the Jib one. So if I were to do that, I will see that there are two of them. There is the Jib one and the Riff-CNB one. And if we look in detail here, so remember, a build or build template is a series of steps, and each of them is actually implemented by an image. And the contract is very simple. Either it succeeds or it returns an error exit code, and in that case, that stops. That's all there is to do. So if we look at the different steps, you can see first that you define a build template with some parameters that you can provide. You can give them default values and descriptions to help the user. So this is what we did, defined a couple of parameters, like the artifact and the image that's going to be created, stuff like that. And then if we look at the steps, I guess the important ones are here. So the build packs, the way build packs work is that they have a two-phase thing in a way. There is the detect phase, which runs for, so what we're actually using should be called a builder. It's made of several build packs. And so what it does is that for each build pack, it runs its detect phase. And the detect phase looks at the code and decides whether or not it wants to participate in the build. So maybe it's going to look for a pom.xml file, and if it finds one, it's going to vote, hey, yeah, I'm going to build this stuff because I know how to do that. But maybe for, let's say, Node, it will look at a package.json file or something like that, right? So it runs the detect phase in turn. Each of them needs to answer, and if at least one of them answered yes, then it's going to go to the build phase. So again, for each of those that answered true, it's going to run their build section, and they can communicate between each other via this thing called the build plan, which is a shared document. And so results from or information from a previous step and from a previous build pack can actually communicate to later phases. And for example, in that case, the build pack responsible for building, let's say, Java from Maven can instruct that, yes, it did build Java. And so the Riff part is going to look at that and say, okay, it was a Java app, so I'm going to apply the Java invoker around it and make it executable in the concept of Riff. So this is what's happening. It's a bit more involved than that, especially you see the analyzer phase and stuff like that. So that's pretty smart, because what it does is once it's built, it reasons in terms of layers, and it tags the image that you build with some information that when you later build that application in the same image, grabs it, looks at the labels there, and sees whether or not some of the layers have changed given their digests, and it can reuse them. So for example, when you have, I don't know, for a Java app, you have all your dependencies all there. You don't need to recreate that layer if it hasn't changed. So your build back can skip that phase. So yeah, this is what happened, and it's built already. I don't know if I invoked it yet. Yes, I did. And this is all there is to know about build packs, and we'll talk about invokers a bit more later. So this was Knative build. And let's move on now to the eventing part. So again, eventing is defined in some of the repositories for Knative as a way to allow your app to be defined in loosely coupled ways, and introducing message architectures that allow you to decouple both in time and space the different subparts of your system. And so it does that by introducing a handful of new CRDs again. Some of them are currently changing, but the concepts are going to remain the same. The central one, I guess, is the channel. So a channel is just a name that is a name for a topic or a conduit that will be backed by something, by a middleware messaging system like Kafka, Google PubSub, or something. But now that you have that concept of a channel and you can give it a name, it can be used to wire together several pieces of your system. So you do that by creating a subscription. And a subscription is just the wire information that says, OK, I'm going to wire that channel to that endpoint. And there is something that continuously, again, everything that we explained in the very first hour is still relevant. That is continuously looking at those channel and subscriptions. And if there is a bus dedicated to, let's say, Kafka, and you created a channel in the Kafka bus, then it's going to register anything that is needed in Kafka to accomplish that. So it will typically create a topic. But other implementations may do something else. And as a matter of fact, when we installed Riff and Knative, we didn't install any bus yet. So we get one that is very basic called stub. And we're going to show that. There are other concepts like sources and flows that allow you to do more complicated stuff. But because it is a bit, the API is a bit evolving, I'm not mentioning that today. So let's try to see this in action. And how would you use that to decouple your app, and you know, what benefits would you get? So currently we have that Square app, right? It's there, and I can invoke it as I did directly. And this is getting traffic from the outside. That's all fine. But what I would like to do now is to combine it with other stuff. And because the channels that I'm describing there are not publicly exposed, they're a private thing to your cluster, then I will require something, a new application that is going to front the whole thing so that I can access them. So we're going to create a new app, a new service for that. It's already built, and it's easy to do yourself, and I can explain how it behaves. But the important part here is that we're going to create a channel named numbers, and it's going to hold the numbers before they are squared, right? Then we're going to create another channel named squares, which will hold the result of applying the square function. And then, but at that time, they're just sitting there. The channels are not wired. So we do that by creating a subscription. And in that particular example, we specify that the channel is numbers subscribed to the square thing, and the reply of that goes to squares, sorry. Then we had the greet function from previous run, or we could deploy a new one. And what we're going to do is to wire that up as well. So we're creating yet another channel, the third one, and wiring the squares channel as the input to greet, and the output of greet shall go to the replies channel. And lastly, we are going to wire the replies channel to Correlator, because it may need to receive the result of this whole thing. And as I said, the Correlator thing is a very small app that knows how to talk to the channels service, Kubernetes service directly. And it's implemented in a way that when you request, when you do a post on /foo, it sends traffic to the foo service for that channel named foo. So let's do that. Okay, how much time do we have? Do we want to script this? Or
yeah, I think there's time. Yeah.
There is time?
Yeah, I think
so. Okay, so let's do that manually and fail miserably.
It'll be fine.
So, as I said, I'm going to create a first channel named numbers, right? And I said we're going to use the bus named stub. So what this does is that it's not using an actual persistent system like Kafka or PubSub or whatever. It's just in memory. So it's good for demo purposes, and as soon as it receives a message, it's going to dispatch it to any channel behind this downstream. So if the channel is not there, the message would get lost. If you're using an actual proper bus like PubSub, then you could send traffic to a channel, and if there is nothing to consume the message at the time, it's not a big deal, because when it comes up, it will receive the messages. So this is, I guess, a point to consider. This is one of the benefits of such architectures, is that you can decouple the subsystem of your application so that you can update them independently. Also, you can have one channel that is subscribed by several pieces, right? So posting to one channel can like fan out to several services. So let's do that. Let's create the squares channel. So if you remember, that's the result of the square application. And then we wanted to subscribe one to the other. So Riff subscription create. The channel is going to be numbers. So that's the input to my function. The function is square. And we want the output of that, so what's currently named reply to go to squares. Okay. We want to do the same thing with the squares, which are going to go to greet. We didn't name it greet, correct?
I forgot the name, to be honest. So the subscriber name has to match up with the name of the actual service. So it's called greeting.
Greeting,
yeah.
Okay.
Yeah.
So greeting, and the output of that is going to the replies channel, which I haven't created yet. Okay, then let's create the correlator thing. So we saw previously that with Riff you could create a function from source, but you can obviously deploy a service from an image, if you will. So Riff service create dash image. Should be good. Nope.
The name of the service?
Yes, it's going to be Correlator. There we go. And we're going to wire that the very last step, so from replies to Correlator. And then we're good. So from replies to Correlator.
Now, of course, this is just this is also creating the channels and subscriptions as a resource behind the scenes to Kubernetes master, right?
Yes, absolutely. Yeah. This does a push of a document, so to speak, and there are controllers which react to that, just as we saw previously. So obviously, I can still invoke those services as before, right? I can invoke them directly if I want to. So, for example, I can do. I guess I can look it up. Can invoke them, but this is not using the channels. This is going directly to them and invoking them, right? But what we want to do here is a bit different. We want to see the whole thing using the channels, right? So let's invoke the correlator. And as I said, if I use that particular path, it's going to send traffic to the channel at that path. What did I do wrong?
Check it out. So it posted the message to the channel.
Yes.
And Square is spun up. There was nothing running because it was scaled down to 0. And so Square received the message and processed it. And yeah.
And I found the backslash key. It was still not there.
What are you looking for? They would not.
We're not.
Response,
okay,
right?
yeah, let's me do this.
Yeah.
So you can see here, so I added -v to the curl thing. You can see that the result we get is a 202 HTTP code. And so it was pretty instant, right? What this does is that it accepts, the correlator accepts the payload, forwards it to the channel, and then returns immediately, but gives us a correlation ID thing that it created. And this is one way for you to then later, assuming this takes a lot of time, to then later ask for the result. But to make sure that this actually works, we could be tailing the logs. And I guess I'm gonna get the name of greeting.
Oh.
Yeah, I'm not used to that touchpad. Oh, come on.
It's a greeting 00001.
Let's focus on the user container only. We can see what's happening. Okay, and you can see that we're logging hello 49. So what happened is that the first function got invoked, and the result for that went through to as the input to the other. If we have a bit more time, we could show how to get that result from the client's perspective. So there are two ways to do that. This is what the Correlator app does for you. Again, you could do anything you want really here. Either we request the issue a get and a polling get, so to speak, with that correlation ID, or we ask the Correlator to wait before it returns the result back to the user and internally use that correlation ID to look up the value. So if I do that by specifying a custom header, I guess could do like this. Get that right? Yep. You see, it actually took time to reply. If I'm doing the -v as well. This time I'm not getting a 202 accepted, I'm getting 200, regular 200, with the actual result of the invocation. So the correlator was responsible for storing that. In the real world, you would put that in a persistent state and use that key somehow. So I think that covers the eventing part. Again, the benefits of that is that you decouple your app both in time and space so that you can update your system, some part of your system at some point in time and not the other, or that you can scale some part of your system and not the other, etc. Is that good? I guess this is time for a
10-minute break.
10-minute break, and when we're back, we're gonna create a whole application from scratch, I guess, seeing everything we saw.
Yeah, using Spring Cloud Functions, yeah.
Absolutely.
Yeah, so be back in 10 minutes at 3:40, please. Yeah, thank you.
Thank you.
Yeah. All right.
All right, we're back.
Yes.
Thank you again for being back for the last part of the presentation. Before we go there, two things, I guess. Let's have a quick recap of what we saw already. And also, I'd like to take this opportunity to tell you about a question I had during the break, which someone told me, but it's a bit weird that you create all those channels by hand, all those subscriptions by hand. It's pretty cumbersome, and that's totally true. And if you remember correctly, at the very beginning, I mentioned that I worked previously on Spring Cloud Dataflow, and also I skipped some of the concepts in eventing, which I told were higher level concepts. And indeed, you wouldn't deal with subscriptions and channels by hand. You would use higher level concepts like a flow, which goes, I don't know, HTTP pipe, filter pipe, log or file, and in turn, something would create the subscriptions and the channels and all the nitty-gritty details for you. So that's a good point to be made, I guess. And so if we are to recap what we saw already, we saw how Kubernetes works, how you typically extend it using CRDs, and indeed Knative is using that mechanism with dedicated controllers, introducing some new concepts, especially in serving, the concept of a service, configuration, revision, allows you to scale to and from zero and to route traffic as you see fit. The build part can be used to automate building of your containers from source, and it can be used in conjunction with serving so that you can say that your service is actually the result of a build. And the eventing part introduces the concept of channel, bus subscription, so that you can decouple your app in several subsystems. And Knative is a platform for platforms, so it allows you to build on top of that. And indeed, Riff, which is a function as a service offering, uses that, and you wouldn't deal with Knative directly. And once this is done, I suggest we try to create something almost from scratch and real-world use case.
Yeah. So, so the thing that we're going to build is maybe something that it has to have a cat in there, so obviously. I think that most of the examples that you see are like squares and uppercase and I don't know, stuff like that. Yeah.
So you're making fun at me again?
Like also me, like greetings and hello world, right?
Okay, so a cat is better. That's what you're saying.
If we can do something with cat, that would be pretty awesome. During one of the presentation I was preparing with Josh in the past, it's like, written in uppercase, what if we can do an upper cat?
Upper cat.
Yeah, how do you uppercase a cat, basically? So basically, what we're going to do is that we're going to operate on the picture of a cat and do something with that. So, so this is going to be called uppercat light, just because of the existing thing that we have. So I think one of the things we're going to build is a little function that will analyze the picture, the image that we're going to upload. And first of all, we need to determine this is a cat or not, right? So
definitely production ready then.
Yeah.
Contrary to square or
exactly. Yeah. Cool. Exactly. And of course, we're putting a cat onto the channel somehow into Knative. And we don't know if this is going to work. So by definition, this is going to be a Schrödinger's cat in a way. Because we don't know if it's going to come out dead or alive. I have no idea. Because we're going to be doing a lot of these things just live. So we will see. Yeah.
Yeah, let's do that. Yeah. And so we're going to use a JVM-based function our app.
Yeah, because that's the only language I know. I only know Java and Kotlin. I know a few other things, but I'm not comfortable with any of those other things myself. So I'm going to write a Java function for that. And specifically, I'm going to use Spring Cloud functions to write the functions and stuff. Now, Spring Cloud function is really just a framework that allows you to define functions with functional interface and the beans, and then you can actually deploy your Spring Cloud function to different target environments. So Riff is potentially one of the targets, and you can deploy it onto different cloud platforms with Spring Cloud function. And also the other reason I want to use it is because then it allows me to use all the Spring Boot features. So I can have some auto configurations and dependency injections and stuff that's coming directly from Spring and Spring Boot, and I can just wrap all of that into a small function for that matter.
Okay.
Yeah.
Because I guess, a Java function is something that implements Java.util.function. That's just that, right?
Yeah.
And so in itself, it wouldn't run.
Yeah.
You need something around it, and you need, especially if you want it to run in Knative, you want it to conform to the Knative contract, which is basically to answer to HTTP requests. And so this is what Spring Cloud function gives you. It turns anything that is a java.util.function into the app. And indeed, this is what Riff, when it's building a Java function, this is what Riff is using. It's through the concept of the invoker. So I used that word throughout the session, but didn't explain it in great detail. What we call it, the invoker, is the thing that knows for any given language how to turn that into something that Knative can understand and reflectively sometimes invoke it. So for JavaScript, it's going to do require of your source in a way. For Go, it can load a Go plugin, stuff like that. And so for Java, it is using Spring Cloud function. This is how a function would look, right? It's a class that implements java.util.function, some input type, output type, and your business logic here. So notice that your function isn't tied to any framework at all or anything, right? It doesn't need to be. Obviously, if you want to use Spring, you can, but it doesn't need to be. And then the invoker, which in our case Riff provides for you, is the thing that would run it. So it provides the main entry point. It's actually a Spring Boot application, and then through a auto detection mechanism, it can turn your thing into a invocable endpoint. So your function just has to be a bean. That's one of the ways to do it.
So I guess what you're saying is that if I write a little function, my jar, which just has this one class,
it could absolutely.
And then if I deploy this one class into Riff, through the jar, through the build pack, it's actually gonna add Spring Cloud function, the invocation part of it,
yes,
and then automatically detect potentially where the function is, and then start up the web server, listening on the port 8080,
yes,
and then know to invoke this specific function.
Yes, there are different ways to specify that and force that, especially if you have several functions in your jar. But yes, definitely. And this is what it does. And when you specify the artifact, we end up doing that.
All right. So why don't we go ahead and build something here? Let me see here. So I will go to my awesome place here, Spring Initializer, of course. But I'm going to do something here with I'm going to add an actuator here. But because I'm going to use some ML API to determine whether the picture is a cat or not, so I'm going to use Google Cloud Vision API to do that. And we are using the GCP support. What this will do is to add Spring Cloud GCP to this project. So you can see that we're going to be creating a function that also can interop with all the other starters as well. Specifically, this will be Spring Cloud GCP, which will help me bootstrap some of the basic credentials that I need to access the Google Cloud APIs, and also allows me to, say, use the other services too, like a Spanner or Cloud SQL, or add trace and whatever that I need in my application. Okay, so here we go. We'll see how this works. We don't know the outcome yet, so we will see the outcome when we see it, right? When we observe.
Cat.
Yeah, when we actually make the observation of whether the cat is alive or not, but hopefully alive. So here we have the basic Bootstrap code here with POM, with Maven.xml. So first I need to just add the Vision API to my app. So I'm going to do the Vision API. And it's coming from Google Cloud. And because I'm using Spring Cloud GCP, I don't actually need to specify the version of the client library. That is because we import the BOM already. So the BOM actually have specified the version for me already. And then I need to write this function. Now, this is a Spring Boot app by default. And when you generate it, it doesn't have to be a fully, full-blown Spring Boot app. It's just that it is generated like this way. So I'm not going to change anything to that extent. To use the client library, I first need to initialize it somehow. So let me see if I have it. Image, no, I don't. So I'm going to create a bin, and this is going to be, it's called the image annotated client. And I'm going to say image annotated client, and it's going to return the instance of my client. So the Spring Cloud GCP auto configuration actually will provide me something called the credentials provider. And this will automatically discover the credential I need to make the call to my APIs. This can be a JSON file like the one that we saw earlier that we used. It will be known as a service account. Or it can automatically discover the credential that's associated with my servers or on my machine through G-Cloud authentication. So I'm just going to use the default way of doing that. And then I need to create a client with a setting. Okay, something along this line. And then I can set my credential provider as I'm creating the new client. Okay. Now, what this will also do is to, because the clients are actually heavy objects, what that means is that you don't want to create a new client every single time you want to make a call. So this is a heavy object, so this is going to be a singleton by default. And it also implements auto-closable so that this bin will be shut down properly when you shut down the application. That's the desirable characteristic of it. So it's important to return this bin as just managed by Spring. And then I need to create a function. So I'm taking something from a string. So because we're going to base64 encode the cat, so we're going to base64 encode the cat and cat it into this function somehow. And we're going to return the string of whether this is a cat or not. Okay. So first of all, we need to import this function. So we're going to do that. Oh, there we go. Oh, no. What happened? So let me do the import. There we go. Import class. So this is just a Java util function. And we need to mark it as a bin so that it gets picked up by the Riff invoker as well. And I'm going to code this cat, not cat, cat, not cat. Oh, cat, not cat. Yeah. So I don't know if anyone watched this other series where they have something called hot dog, not hot dog. Yeah. So it's basically something you put a picture of a hot dog and tells you whether it's a hot dog or not. This is basically whether it's a cat or not.
That's how you make hot dogs in the first place.
Yeah.
By the way. But,
yeah. Whoa, no. I don't think that's how you may know.
Sure.
Probably not. Hopefully not. Hopefully not. All right. So, so here I'm going to take the image in, and then we're going to return this via a lambda. And optimally, we're going to return a string, whether it's a cat or not. To lessen the boilerplate a little bit, I'm going to get this thing. Oh, hey, look at that.
Yeah, it was.
I have the answer right here. So. So let me just paste this in right here. Yep. Cool. So actually, you know what? That's not the one. So that's the wrong one.
The one you were looking for before.
Yeah. No. So that's OK. So what I'm going to do is, oh, look at that. How convenient. Yeah, there we go. So what we're going to do is to basically invoke the client, which is called the image annotator client. And then we're going to do a batch annotate on it. And then this will take in a list of the requests. And we're just using a Guava utility here to create a new list. And then we're going to, in this list, we're going to have a annotation request. And then we need to import the, specify what the image is. Yeah, that's definitely really, really awesome. And then ultimately, we're going to, we'll take a look at what happened here in a second. But we're going to set the content. And the content is going to be coming from the image. And remember, the image will be base64 encoded, so we're going to decode it. And then it's going to become a byte array, and then it's going to become a byte string. And then we're going to build this, and then we will eventually do this as well. With the picture, we need to tell the API, like, what do I want to detect in it? There are many, many different things we can detect via the API. So what I'm going to do is to set the type of this to label detection. So we can detect landmarks. We can detect face landmarks as well. There are many different things that we can detect here, but specifically, I'm going to do the label detection. And let me see if I think it's just the wrong version of the list that I imported. Yeah, that's the wrong one. So there we go. So let me make sure that I'm using the Guava one. There it is. And that should be it. So that's going to give me the response from the image vision API detection to tell me a list of labels that's being detected. And because I pass in one request, I will have one response that come back. So I'm going to grab that response. In this response, I'm going to have the list of label annotations. So like whatever it sees from the API, whatever it sees that's in the picture, is going to give it in a list for me. And I'm going to stream it with Java 8 streaming, and I'm going to do any match. So we can do some, we're going to go through each one of these labels and say what's actually in there. So I'm going to say if the label and label dot I'm going to match on the description is equal to cat. That's one of the things I'm looking for. And I want to make sure that the score is high enough, so we're pretty certain that there's a cat in the picture, right? So that's a cat picture. And that will give me the Boolean here to say whether there's a cat in the picture or not. And then we can say return based on this. So if there's a cat, then we turn cat. Else, not cat. And that's really it. Is that
You're not in Kotlin.
What's that? Oh, I'm not in Kotlin anymore? Yeah, sorry. So why don't I write this fully so that, yeah, there we go. I need to do the return not cat. Yeah, there we go. Yeah. Good call. All right. That was pretty verbose. Whew. All right, done. So what we're going to do is hopefully this will just work. I don't know. Like that. I'm not going to spend a lot of time testing it, but this is what I'm going to do.
It's important to point out that you could test it in a unit test, because your function is just that, a function. So if you can mock the dependencies you have, etc., you don't need to test it in a full-blown environment. You can just apply unit testing or even mocking there if you want. But we're going to build
tell you what, I'm a little worried right now because we don't know what the outcome will be. So I will try to build it. And oh, look at that. So that is also because I'm running Java 11. So let me just go ahead and do the new, just go back to Java 8 for a while. Yeah, it always seems to be a little bit more stable right now. So we can see that this definitely will compile. If it compiles, it runs, right? It compiles, it runs, yeah. So anyways, let me make sure I got the beans.
It can run in the wall, but it runs. Yes.
So I'm going to go ahead and initialize my repository here. Woo. And I'm going to add all the files, git add everything, right? Git add dot, yeah, and git commit. Because the initializer configured the git ignore already, so I'm going to say initial commit, right? That's what we do. And then I'm going to go ahead and open this up in GitHub thing. Oh, where am I? Yeah, so let me do a GitHub dot, and that should open this up in the right place. No, let me quit it. GitHub dot. What?
It's so small.
Yeah. I mean, what is going on here? Remove. I don't know if that was a good thing that I just did. So let me do a GitHub dot. Yeah, there we go. All right. So OK. Whew. And then I can publish to a repository. So let me make sure I have all my files here. Yeah, I do. OK, good. So I'm going to do a cat, not cat, Devoxx. I think that's something I'm going to just create right now. And this will create a repository for me, and then push everything up there, and then set up my remotes.
Yeah, this is just a way to create a repository on GitHub quickly, right?
Yeah.
You obviously don't need to do that.
Exactly. So if that works, and if I go back to here to git remote, I can see the remote here. So now...
So we can build it as a function if we want to.
I hope so.
Do you want to do that?
Yeah, I'm just a little scared to do that, to be honest.
Let's do it.
I mean, who's done this, right? So here's the code, right? And here are the things that we committed. So why don't we just go ahead and give it a try?
Sure.
So how do I do that? Remind me.
So Riff function create.
Riff function create. Yeah.
Give it a name.
OK, create. I'm going to call it cat, not cat.
OK. Then the Git repo that you have the URL for.
So
--git
repo. Yeah.
And that.
Like that.
Then you'll need to push it to some image. So gcr.io/GCP project.
Oh, GCP project, very good.
Something.
Cat, not cat, Devoxx. Something like that.
And then we need to provide the handler for your function. So currently we need to provide, which is basically the bean name of that implements your function. In the future, if there is only one, it will be auto-detected.
I see.
But for the time being, you need to put cat, not cat.
So that will be the name of the bean. So that will be the handle here. So if I write just a regular function, like a Java function, that a class that implements function, then I just add the fully qualified name to the class, right?
You could do that as well, yes.
So it's really intelligent in terms of whether it looks for the class or looking for the bean in this case.
Yes, it can.
Okay.
Yes.
All right. Anything else? Verbose? I think
verbose is always fine, and I think we're good.
You think we're good? It better be good. Yeah.
If it's not, we can delete it and retry, right?
Yeah, that's true. That is true. Yeah, that is true. So let's see how this works. So I just created the function with start.spring.io. I added a little function there with the adding annotation, and then I just checked it into my Git. I push it to the repository, and then I'm just deploying this with Riff function create that will hopefully check out my function for me, and then run through Maven to do all the build, and then add the invoker to it. It seems like it's gonna work.
It is.
Yeah.
So you see, it's saying
using
Maven. It's Maven repro. So what the build pack does here, it looks at different languages that it supports.
Okay.
And it didn't see any JavaScript stuff because you said you don't.
Yep,
know
I don't
JavaScript.
know how to write. No,
I don't either.
Exactly.
This is why I just do squares, by the way. But here it detected that it's a Maven app because there is a pub.node.xml. So it built it, and then the Riff build pack part of it at the very end gets the Java invoker, which is built on Spring Cloud function. Yes.
Yeah. Okay.
And sets it, and you can see the entry point of your application is actually to run Java with the invoker and just setting function.uri equals something.
This one right here. So this is basically setting it to my app, and we're going to look for the cat not cat bean. And oh, look at that! It actually ran. No, it didn't. So so wait a second. What is this? Oh, you know what? I think I remember this. So what I'm going to do is to show you the error messages here. So cat not cat. I'm going to see what is happening here. Remember, we do have multiple container here. So here we go. Let me see the container. And we have an exception. What happened?
That's Java. JavaScript doesn't break with so many lines.
Yeah. So actually, we know this exception was going to be here. And here's the problem. When we started this application, it's actually looking for some credentials. And currently, I have it configured so that it does not look for credentials in a file path. So like the service account, all of that is not actually present. So the second way of getting credentials here is that the client library actually actively reaches out to a metadata server that's only reachable from this machine. And it will return the credential from this particular request if I make the request from the machine. This is known as a machine credential. And the problem here is really that because we're running in Knative, which is running inside of on top of Istio, Istio will block off all of the external facing communications by default. So what happened here is that my application couldn't really make a call to my metadata server at all. So my application cannot make any call out to my APIs. So to fix that, what I need to do...
So you could fix that and configure Istio to allow it to do that. Or maybe there is another way to deal with authentication, which is what we're going to do, right?
Yeah.
But there are several answers possible.
Yeah, so one of the ways, of course, is to configure Istio to allow me the access to my APIs externally. So what we can do here is to create something called the service entry. And this is where it's really important to understand some of the underlying features of a platform, because there are going to be a few layers that you may have to deal with. And sometimes these layers, you have to make changes to these layers in order to make it work for you. So in this case, what I'm going to do is to create a service entry that allows me to, via HTTPS, it allows me to bypass the service mesh and go out into the public internet. And similarly, I need to grab the credential from my metadata server, and these are the internal addresses I can hit. So let me go ahead and just update this as well. So I'm going to apply the GCP service entry. And now, if I go back and if I delete my path to force a restart, hopefully this will start again. That was a close call. Now,
I'm confident.
Now, if this actually comes back and crashing again, then I don't know what to do.
Okay.
So here we go.
We'll take questions.
Yeah. So here we go. So let me see the logs. Oh, of course, I always forget user container. That's what I need here.
It is not in a crash loop, so it's looking good, I guess. Okay.
All right. Very good. So we have
try
that.
It?
Yeah. So we have to test it out, right? So let me go back up here. So we do have a picture of a cat. Here we go.
Always.
And if I recall correctly, yeah, I took the picture of this cat. Yeah. This is on my Flickr. You can find it on my Flickr too. I think this was a cat that I took when I was traveling in Tibet, I think. And of course, to check, it's very easy for me to fake this and say return cat for everything I put in. So to double check this, I also have a picture of a dog. But incidentally, this is my profile picture. Yeah, this is my profile picture for my Google+, which, it's OK. Anyways, so
maybe it's going to answer right Tsang.
Yeah, maybe. Yeah, maybe it's not enough to say this is my dog. Anyways, so what we're going to do then is to base64 the cat, and we're going to pipe it into my endpoint, which is, what was that called? Cat, not cat. And here's where we need to go back and find the route. So let me go ahead and find the route here. Find the route, -o YAML for the cat not cat route. Hopefully cat not cat.
So you could use Riff service invoke to do that as well.
Oh yeah, that's right. I do. Yes. So that's definitely an easier way to do that.
Is it?
So,
okay.
Yes. So let's do that. So I'm going to do.
But not through piping. Either through.
Would it not work? It might work.
Okay.
Well, let's try it. So cat not cat. I think it might.
I don't think it will.
No, you don't think it will? I think it will. We'll see. We'll see. And then we do D, and then what is that? H, content type. Oh boy.
No, you.
Wait. I specified already.
Yeah. So that's good.
So that's it. And then maybe a W with the N. Oh, actually, you wrote Riff, so you probably know whether this is going to work or not.
Sure. I'm wondering if the standard into that goes into curl, but
let's find out. So hopefully the base64 picture of the cat is being posted to my function. And my function was actually stopped earlier because no one was using it. So we're reinitializing it. So we're starting this cat function again, or cat not cat function again. And then once it starts running, what happened behind the scenes is that if I actually have a readiness check configured, then the activator, what we saw earlier, would only post the picture to the service when it's up and running. However, because I didn't set up the readiness probe, what happened behind the scenes then is the Istio's circuit breaker actually kicked in, and so there was going to be doing a retry. So as soon as the application started, even though it's not ready to serve on the endpoint, the activator actually tried to post the picture to that endpoint, and so it failed, and so it's going to do a retry loop again. But apparently, it actually works.
It did.
It's a cat.
I'm amazed.
Yeah. Well,
that's because we forward the standard in, so that's good to know.
Yeah.
And we can try with the dog.
So we can try it with the dog and see what happens. Cat, not cat, and not cat. Yeah. So we know it's a dog, and we know it's a cat. Yeah, that's pretty good.
Pretty good.
So yeah, thank you.
Yeah, that's all on in.
Woo! All right, maybe we should stop on the high note, yeah?
Maybe.
Well, let's see how much we can do. So then what we need is maybe a little, we can do a little bit more. most times we probably don't want to just base64 encode a picture into it.
Yes.
Maybe
you don't
we
want
just
to do that yourself, right? Maybe if we had a service to do that or a function to do that.
Yeah, to just give it a URL, and maybe the function can take the URL. So imagine you're triggering an event that just gives you a URL, and then the URL will get to the function. The function will just produce the base64 encoded image, and now you can tie up your business functions together with the channels, maybe.
Yeah, seems like a good use of them.
Yeah, so why don't we do that? So let's go ahead and create a new function here. So I'm going to come back here. Now, for the sake of time, I'm going to use Kotlin because you're gonna like it because it's gonna be so much easier when you say what we can do to turn from URL just to bytes and then base64 encode it. So I'm going to code this function image source, but actually because this is Kotlin. What I'm going to do, I'm actually going to do something different here. I'm going to push this into an image myself. So I'm going to use Jib to create this image myself, just to see how they all interrupt based on what we learned. And we can actually add the web thing here. What this will do is actually add the function invoker directly into my application that will also automatically discover the functions for me. So I'm going to go ahead and create the image source, open this up. I don't really need GCP support, so I could have gotten rid of it, but I forgot.
Doesn't hurt.
That's OK.
Yeah. And I guess we should mention that this is because the Java Invoker is using a rather old version of the Spring Cloud function
in
stuff
Riff.
In Riff. But as soon as we update it, it will support Kotlin functions, if I'm not mistaken, right?
Yeah, exactly. So this is basically we're embedding a the newest version of the function invoker here. And you gotta remind me how to write a Kotlin function. So it is image source, something like that. And then we're going to return a unit, which is going to taking a string, and then we're going to return a base64 encoded string. And then here we can actually return the actual lambda, the function itself, which will have the URL that's being passed in, so we can type it. And then we need to return the string. So here's how you do it in Kotlin. What you do is you create a new URL. So as you can see already, there's no new thing here. We don't say new URL, we just say URL. And then it actually have this really nice convenient extension method on the URL, which is read bytes. And I can just convert this into bytes. So that will become the bytes that I read from the URL that I pass in.
Yep.
Right? Yeah, I think so. I hope so. And then what I'm going to return then is I need to get the encoder, and then I'm going to encode the bytes into it. Bytes. And of course, this is probably going to add me 2 strings. Is that right? Oh, wait. Let me make sure that I have the right thing. So here we have encode. Encode to string.
Yeah, you don't want the toString of a byte array, which is going to be byte square.
Exactly.
Right?
So I think that should be it. So I take the bytes in, I base64 encode it, and then I return this on the lambda, and then this will be propagated out to the channel.
You didn't even write return.
I did not even write return. Yeah, exactly.
Amazing.
Yeah. So there's it will take the last output here as the return of the lambda. So so remember what we did here. So what we're going to do here is because we want to have everything embedded into one place. So I'm actually going to add the Jib plugin here myself. So let's see if I can add Jib. And
so this shows that, again, we can mix and match different types of applications, and you don't need to use Riff to always build functions. You can deploy services that are already pre-built. You can build them locally. You can build them on the cluster. You can build in any language if it's not supported, for example, and use an image. And as soon as they kind of interrupt with currently HTTP, you're fine.
Yep. So let's see if this one works. We'll find out. So if it compiles, it works, right?
That's what you say, yeah.
So it compiles for sure, and then we're pushing it with Jib into a container. So imagine if you have your pre-made containers here already, which is fine. But we're just gonna push it right here, right now. Hopefully this would do it. Come on, internet, you can do this. Do not die on me at the very last moment. The previous one worked really well, right? So this is another argument. Maybe I should have done this on the server side and through the build template. Yeah. but we'll see. And oh, there we go. Good. Whew.
Good.
And then now we can go ahead and deploy this thing based on what we learned. And to deploy the container, we use Riff service create. Is that right?
Riff service create. Give it a name.
Name, which will be image source.
Yeah, and just the image. So -- image.
Okay. Is that?
Yes.
That's it?
Yep.
All right. Yeah, I always type too fast, so I always hit enter before Eric says we're done. So I always have to double check.
Yeah.
So here we have the image source. Oh, OK, it's up and running. And of course, we can invoke it just to make sure it all works. So let me see here. Why don't we go to my Flickr, because I do have a lot of things in there. Maybe we can find another picture.
Including cats.
Huh?
Including cats.
Yeah. Do we want a cat there or no cat there? So I'm going to do a search here. And if I can do a little search and look for a cat. I think I have other cats. I don't know. Maybe I have a dog. Yeah, I got. That's interesting. So there's obviously something wrong. The dog came back when I'm searching for a cat. But oh, look at that one. That's kind of cute. Oh, what about panda? There we go. OK, then why don't we do that one?
It's
all right.
The Vision API. We'll see, right?
Yeah. So here we go. I'm going to download this small version of this. I'm going to code this panda. OK.
Sweet guy looks like 49% like a cat to me, but
wait a second. Yeah, exactly. So what I need to do is actually get the URL for this panda.
For the actual image, yes.
Yeah, there you go. And then what I can do is hopefully do a Riff service invoke. Is that right?
Yes.
Invoke.
So name of the function, which is image source, dash text, because the URL is a text, -d, the value, and yeah.
And hopefully this will give me back the base64 encoded version of the picture.
Yeah, I can see the panda there.
Woo! Yeah, totally. We should put this on a full screen, just like metrics and letters falling down the screen, just like that. Yeah, anyways.
OK, cool.
So now we can tie everything up together.
Yeah, but so we need the output of one function to be the input to the other.
OK.
That reminds me of something.
So then we create a channel.
Channel.
OK, so what do we do here is we do a channel create.
Channel create, yeah.
Oh, sorry, not create channel. I see. So channel create. Since you done all the eventing earlier, I'm trying to learn this myself. So we do channel create.
Do you want to use the stub bus?
Oh, right.
Or
so
are you like really...
Am I really like on the edge right now?
15 minutes.
Yeah, 15. So what we can do is we can either do the stub bus, which will be like in-memory bus, and if the cluster goes away, you have no persistence to the image. So what we can actually do is, remember, the bus actually hides all the underlying implementation of the actual middleware. So what we can actually do, if we want to, should we? Yeah, I guess we should.
Your call.
Yeah.
You're typing.
A lot of faith in here. Yeah, so what we can do is actually install a class bus, a bus that's backed by Google Cloud PubSub, right? So PubSub is just our messaging system that we handle, a lot of messages over. It's completely serverless in a way because you don't actually need to maintain your own middleware system here. You just say enable the API. I want to use PubSub, and there is something we need to do to actually configure it and deploy it. First, we need to tell the bus which Google Cloud project we're trying to use. So this is one of the easy way to do it by creating a config map, because the bus actually refers to this config map. And then we need to add a credential here so that we have so that the bus actually have access to the PubSub API with a specific service account. This is very similar of what we did with the builder, right?
Sure,
so with Riff, we added a service account with Riff, but here we're going to add a service account here as well. So here we have the keys, and then we have the PubSub service account that we're going to use as well. And then all of the bus stuff is actually stored in a file somewhere. You can kubectl apply it from the web, or in this case, we can do it directly from the file that we have here. It's really nothing too much interesting to look at in there. It's really just a bunch of controllers that need to be deployed, and that hides and honors the bus resource definitions, so that whenever we create a new channel that's specifically addressing to be part of the PubSub, and this controller will actually create it for us.
Yes.
Okay? So, I don't know. We just did a lot of things here.
And so what is it going to do when a new channel is created? So a channel is just a custom resource in Kubernetes, right? It does nothing on its own. So that particular bus it is going to create a PubSub topic, right?
Yeah. So when we create the channel via Riff, it will create the channel YAML or the resource file, whatever, and then the PubSub controller here will actually receive it, and it will actually act on it and call the PubSub API to actually create a new PubSub topic. And subsequently, when we do the subscribe, it will actually create a subscriber within PubSub as well. So I think it's up and running. I don't know about you, but why don't we just go ahead and create?
I mean, if it doesn't work, we can always use stub. So let's try it.
Yeah, that's kind of true. All right, so there's a lot of things we do need to create in this case. Let me see. Oh, that's not the one. So I guess we have to create everything by hand now.
Yeah.
Yeah, OK. So
I've been through that.
Yeah, so here we go. So what we're going to do is to just create a new channel
first, right?
Yep. And we're going to call it URLs. Is that a fair one?
Yep.
Yeah, URL. And then it's going to be a cluster bus. And then I think here we do GCP PubSub. Is that right?
I'm not sure about that last part, but
yeah. For this, I need to cheat a little bit and just make sure I have all the things properly
Actually,
done.
You can try it. If it fails,
would it fail?
It would
oh, what did you just do? Would it?
Yeah.
Hopefully that just worked. Yeah.
Yeah.
And then we're going to create one that's the output of the URL, which is the picture.
Yes.
Pictures, like that.
Pictures. Careful.
Pictures, like that.
No,
okay.
not pictures.
Pictures.
That's a different thing.
Yeah, got it. And then from pictures, we're going to pipe it to.
We could use replies.
Oh, there we go.
If we want to.
Oh, yeah.
Tie it to the correlator.
Correlator or uppercase. Let's do uppercase. Yeah.
Okay.
So we're going to uppercase the cat in this case. So we're going to create another channel called uppers, right? So that will be the reply of the. Oh no, we can just tie it up, right? So what we can do is now we can do a subscription.
Yeah.
Channel, the URL, and subscriber is image source.
Image source. Sorry.
Yeah, and then reply to pictures.
Not yet. Yeah, you forgot the create, and reply to is, yes, indeed.
Yeah, there you go.
Yeah.
Good call. You know how to use Riff now. That's awesome. Very nice. So Riff subscription create, reply to pictures. Oh, my goodness. And then what we're going to do then is from pictures, we're going to send it to cat, right? Cat.
Absolutely.
And then who do we reply this to? We need to reply it to uppers.
Good.
Right?
Yeah.
OK. Whew. This is a lot of stuff we're just tying up together, by the way. And then from uppers, we're going to subscribe to, what was that called? Get kubectl. No, we got to uppercase it first, right? So where is it?
Oh, sorry, yeah.
Get
KSVC.
Yeah. So we're going to subscribe it to upper. Is that right? I think that's what you code it. And then we're going to reply it to replies, because you already have that wired up.
Yeah.
Right? Whew. So we'll see how this works out, right? So here we go. We're going to do a get again. Sorry, watch get. There we go. Oh, what happened? Oh, there we go. So we're going to watch the pods again, and we're going to see if this actually works, because we only have 9 minutes left. It either works or it doesn't work.
Sure. That's
like
pretty binary.
Yeah, there you go. And so now we need to invoke it. So what do we do with the Riff thing? So with the correlator, so we can do
Riff service invoke.
Yeah.
The name of the app, which is Correlator.
Yeah.
Then /URL, because that's the name of the channel you used.
That's the name of the channel that I'm trying to post to. Yeah.
Okay. And then --text, because you're putting URL is a text.
Yeah.
Then --, and then you start stuff to send to
copy.
curl.
So let me try this first one. So we'll see. We've done this very quickly, but we'll see if everything got tied up together. So ideally, when this kicks in, the correlator will receive it. So we can see the correlator start. Right? It was all shut down prior. Whew. So correlator started and gave me something back. That's fine. And then this thing should have gone to some channels here that will go to the
URL. So the channel now goes to PubSub.
Yeah.
Then the PubSub subscriber sees that there is something, posts it to the image service.
Yeah. Yeah.
Image service should wake up.
Yeah.
Maybe it doesn't. Maybe it does. We'll see.
Yeah. Yeah.
And then you get the result from that. Given that it's a Java app, it may take some time to wake up, but you get the result from that, goes to PubSub again, new subscriber, goes to the cat function. Again, it may take some time to wake up. If we wake it up manually, it will be even easier. And then goes to upper, and then goes back to the correlator. And so we could invoke it in a synchronous fashion if we wanted to. If we want to,
yeah, exactly. But I think there's probably something happening in between where the channels didn't really, the subscription didn't really tie up together, right?
Okay.
So one of the really easy way to kind of troubleshoot this is actually with a Riff subscription list. Is that right?
We can do that.
So we can see exactly what happens here, right? So this is really, really useful. I wish this actually builds a tree of things, right? So
that's coming.
Yeah, that's coming. Oh, that would be really, really cool, right? So wait a second. What happened here is that we have the image here, which is image source, and that will post to the pictures channel.
Yeah, that's good.
Yeah, and then from the picture channel, we have something that will post to cat, and from there we'll post it to upper, and then from upper we go to uppers, which will go to the upper subscriber, and then there will be successful here, right? So.
This looks good.
Yeah, that looks okay, right? So let me make sure I have all the channels pre-created too. So I can also do a channel list as well, right? So we can do a channel list to see if everything, it's Riff channel list. Woo. And check this out. So we have pictures and we have URL that's on the PubSub bus. And then we have all of these things, right?
We don't have uppers.
Oh, we don't have uppers. Is that what I forgot?
Maybe.
You can create yes.
After the fact, I think it will work.
So that's what was missing in between, right? Channel create uppers, and then GCP
cluster
bus, yeah. And GCP PubSub, something like that, right? Okay. So by the way. Because of the time, I'm just going to show you something from within the cluster of what's inside. So for example, if I go to my environment here, and if I see PubSub, if I go to PubSub, there's a really easy way for us to also double check if everything is created. So for example, here we have the image source, we have the URL here, we have uppers, we got the pictures here, and we have the image sources. Did I call it image sources?
Maybe it's from before.
Yeah. Let me see here. Did I have, let me see here. Where is my image sources? Oh, yeah, that is in fact from before, right?
Yeah.
Yeah. So, well,
let's give it another try.
You want to give it another try? Yeah, why not? We'll see. So somehow, somewhere along the way, when I post this into the URL thing, the correlator should have gotten it. It should have posted to my channel, which is the pictures, right? So I can also do this, right? Channel delete pictures or URLs. There we go. And I can also create a new one. Create URL, and then we can do a cluster bus, which is stop in case that the other one didn't work, right? So maybe that's the case. I don't know. But do I have to refresh if I need to change the channels and PubSub and stuff like that?
You wouldn't, no.
No, you wouldn't? Yeah. Well, like I said, this is a Schrodinger's cat. So we don't know what's going to come out from this box at this very moment.
Yeah.
Wait till the correlator get the answer. You have to block.
Yeah. No, what we're seeing now is that it's not even getting there, because the function doesn't wake up. So at the very end, we would do that. That's true. But currently, we're stuck a bit before. But I guess that's
how life
goes.
Yeah. But as you can see, if I didn't tie this up with channels, if I just invoke it directly, that seems to work.
It did work, yeah. Did you invoke that just now?
Yeah, I did. Yeah.
Okay.
Yeah, so for some reason, this didn't really post. I don't know if it's posted to the right channels or not. Oh, it should have. But, it is what it is.
It is.
Well, that is too bad. But imagine if we actually went through, it's going to wake up the image sources based on the new thing. And then it's going to wake up the cat function, and it's going to pipe it to uppercase. And then the end of it, what we should have seen is the uppercase cat if we put in the message of the cat, right? So that's pretty much what it is, yeah. So anyways, because of the time, unfortunately, we don't have all the time to fix this right now.
That's fine.
Yeah, that's too bad. But I promise you, it actually works. So our apologies, but I'll show you on the outside. But just to recap again of the few things that we saw, Kubernetes basics with the CRDs and the controller patterns, that's what's being used over and over again. We have the Riff stuff building on top of Knative. We have Istio. We have serving building inventing. We hopefully was able to build something end-to-end. Yeah. Hopefully. And then if you want to learn more, there are a number of resources you can go. Number one is that we have this, well, there's a Project Riff
IO site, so it has everything to set up Riff in different environments, be it Minikube or a GKE cluster. Yep. So you can do anything in between. Yep. There is the docs for Knative. So Knative is different repos in GitHub. Yep. One for build, one for serving, one for eventing. And yep. The docs one ties everything together and explains the whole architecture pretty well. Yep. And you've got...
Finally, yeah. So finally, we ran a workshop at the Spring 1 in the past where there's a lot of content here, the last link, where it will take you to creating a new function, deploying Riff, deploying Knative onto a GKE cluster, and then you can actually tie up all the channels with the pops up stuff, and then you can see the whole thing run. They actually work pretty well within the lab environment here. So with all that, thank you so much for your time. I really appreciate everyone being here today.
Thank you very much.
Yeah,
and,
thank you.
Come see us if you have more questions.
Yeah.
Thank you.
Thank you.